Hello everyone. In this video session, I'm going to explain part 196 of Java for tester series, that is throws. So what is throws? Throws is a keyword in Java. So what is the purpose of this throws keyword? The purpose of this throws keyword is to ignore the checked exceptions. Okay. Not to ignore the checked exceptions, we have to use this throws keyword in Java. I already explained how to ignore the checked exceptions using this throws keyword in the previous video. In the current video session, I am going to explain more about this throws keyword. Okay, I am going to explain in detail. I am going to explain the throws in detail, guys. Okay, in this video session, I am going to explain this throws keyword in detail. So let me practically show you and explain the throws keyword in detail. So guys, so before I move ahead, I'll try to write a code. I'll write a code which actually gives you this checked exception. Okay, I'll write the code which gives you this checked exception. So let me write. So first I will write this file. File is equal to new file. Okay, or I can directly write something like this. I'll directly write file reader. File reader. FR is equal to new file reader. Okay. So now have to hover the mouse on this file reader. I have to select this. I have to select to import this file reader predefined class from this java.io package. Okay. So the compiler error got partially resolved. Again, I am getting another compiler error which says that constructor file reader is undefined. So in order to define that, we have to provide the file here. Okay. The file object we have to file predefined class object we have to provide here. For that, I can directly say new file of, okay, new file of like this. Okay. New will create the object for this file predefined class, and this constructor should have the path of that particular file, guys. Okay, like this also we can write in a single statement instead of writing in two statements like this. Generally we used to write something like this, right? File is equal to new file, and then we used to provide the path of that particular file here. Where is that path? This is a file path. Copy this, paste, double slash. Okay, right click properties, copy this file name and paste it here. Then the properties, copy this extension of this file .txt, copy this, then paste it here. Like this we have to provide. Okay, we used to import this file predefined class from the java.io. Instead of providing this complete statement, what we can do is we can only take up to here, guys. Okay, so here we used to provide this file here, right? Like this. So instead of doing something like this, instead of providing this file here, we can directly give this object. Okay, so this file is also having the object of this. This file is nothing but the object reference, which is referring to this object, right? The same object I will directly provide by saying file reader fr is equal to new file reader of new file. Okay, you don't have to write in two steps. You can optimize the to single step like this. Fine. Still, I am getting the error, guys. It's saying that you have to handle the exception. Okay, the compiler Java compiler is giving you the possibility that, okay, Java compiler is telling you that there is a possibility of getting a file not found exception for this statement. Okay, this path may or may not be available. Okay, if this particular file is not available at this path, you may get an exception. Compiler is saying that. Okay, this kind of exception is a checked exception, guys. Either we have to handle this exception inside the try catch block or ignore this exception using the. How to ignore the exception? The compiler here is saying that you may get a file not found exception. So copy this. I am saying Control C from my keyboard. I will simply say add throws keyword here. Beside the method, I will say throws, paste it here like this. Okay. Import this from file not found exception predefined class from java.io. Okay, done. You see, you are here using throws keyword. We are ignoring the file not found exception possibility. We are ignoring the possibility of the file not found exception using this throws keyword here. Despite of compiler being saying that there is a possibility of getting an exception in this statement, we are ignoring the compiler words and simply ignoring the exception by writing throws file not found exception. So here we have used throws keyword for ignoring the file not found exception, right? So that's fine. So guys, I'll comment it out for now. I'll remove this. I'll tell you another story now. Okay. So that's what I've explained in the previous video already. How to use throws keyword for ignoring the checked exception. I already explained in the previous video. In this video session, I'm going to explain more about this throws keyword. What is that is, let's say apart from this main method, we have other methods also inside this demo class. Apart from this main method, we have other methods also. Let's say we have another method like public static void some method A. Okay. Some method A is there. And another method is also there. Public static void some method B. Another method is also there. Let's say public static void some method C. So what we'll do is we'll put this particular statement inside this method C for now. Okay. And from this main method, I am going to call this method A. Okay. I'm simply calling this method A. So here I'm able to call method A properly because method is also a static method. Okay, static methods can only access the static stuff. Since this main method is a static and this method A is also static. Okay, this method A calling statement is working fine. Okay, if it is not static, you are going to get an error, guys, like this. Okay, you have to make this static. Static methods can only access static stuff as explained in the one of the previous videos. Now from this method A, I'm going to call this method B. Okay. From this method B, I'm going to call this method C. A kind of chain, method calling chain is there here. Main method is calling method A is calling method B is calling method C, like that. Okay. So in method C, we have this file reader fr is equal to something. Okay. So now compiler is guessing that there is a possibility of this file not found exception. So it's displaying this checked exception here. Okay. So let's say we have used this throws keyword. Okay. So either we can select from here also, guys, add throws declaration, directly add throws file not found exception beside this method C. Okay. So here in method C, we have ignored this file not found exception and compiler has been muted out, right? That means compiler like a warning has been ignored in this method C by saying throws file not found exception. Immediately when you add this throws file not found exception in this method C, which has this particular statement, which has a possibility of getting the checked exception. Okay. As you can see in method B, there is an error coming in the method calling statement, that is method C. Okay. In method C calling statement, you see there is an error. Over the mouse, again it is saying that for now you see method B and method A, they don't have any errors. Okay. But method C calling statement, when I hover, it's saying that you have to handle this file not found exception. This particular statement, which has a possibility of raising the checked exception, is not handled inside the method C. That's why that kind of problem is now taken to this method C calling statement. Over the mouse, again if I say add throws declaration, the compiler error will be ignored by this throws keyword inside the method B also. But as you can see, this method B calling statement is again giving the compiler error. Over the mouse, again it's asking you to handle it. If not in method B, it is asking you to handle in the method A. Over the mouse, here also you don't want to implement. So you want to ignore this checked exception. So throws. Here also the compiler has been muted out. Again, the kind of warning has been gone to the compiler has gone to the method A calling statement. Here also if you say add throws declaration, you see completely the checked exception warning will be ignored. Okay. Checked exception warning by the compiler will be ignored throughout the program. Okay. So if not in the if not in the this particular method, the calling method has to implement it. If not this calling method, its calling method has to implement. If not this one, its calling method has to implement until all the calling methods are completed. Okay. The compiler will keep on asking you to handle the exception until you go to the top like this. Fine. So this is how the throws. Okay, if you ignore throws in one of the method, so its calling method should also ignore the ignore the exception using the throws. Then only it will be, compiler will be muted out or compiler warning will be ignored. Fine. So this is one thing, guys. So what if after ignoring all these levels, if you provide some wrong path, okay, let's say if you have given some xyz.txt here, xyz.txt, this particular file path is not there. In such kind of cases, right click run as Java application, you'll get an exception, guys. Okay, you'll get an exception. Okay, you are simply ignoring it. You are not handling the exception. You are ignoring the exception. Throughout all these methods, you are ignoring the exception using the which one? Throws keyword. Okay, so what is the purpose of throws keyword in Java? Throws keyword is purpose is to ignore the checked exceptions given by the compiler. Okay, mentioned by the compiler. Fine. So guys, so what if I handle the exception at some point of time? Okay, let's say here I'll remove this throws. Here also I'll remove this throws. Okay, here I'm getting this warning. If I surround this with try catch block like this, okay, and write some statement system.out.println, okay, exception. Otherwise here itself I'll write system.out.println, exception got handled here. Exception got handled here, something like this. So in this case, I'm not ignoring the exception, guys. Instead, I am handling the exception using the try catch block. Okay, I can do that. Right click run as Java application. Okay, you see the exception got handled. In this example, as you can see, in this particular method C, we have ignored the checked exception. Okay, so method C calling statement has to handle it. From method B, we have to handle the exception, right? We have to handle the checked exception. So here also we ignored that checked exception. So the method has to handle it. So here there are two options. Either we can ignore or we can handle the checked exception. So here I have handled it instead of ignoring. So you don't have to add throws here, or here you don't have to add any throws because it is handled in this method A. Okay. So the top method also has not to be added with any throws now. Okay. So in this example, as you can see, you have used both combination. That is, you have used throws keyword for ignoring the exception. At same time, in one of the method, you have used try catch block to handle the exception. Okay. So like this kind of things are possible in Java, guys. Okay. Fine. So this is all about the throws keyword in detail, guys. Okay. This is all about the throws keyword in detail, and its purpose is to ignore the checked exceptions mentioned by the compiler in form of compiler error. Okay, compile time error, compiler error, whatever you can say. Okay, so that's it about this one, guys. That's it about this session. In the next video session, I'll explain the difference between throw and throws keyword in Java. So what is the difference between the throw and throws keyword in Java? I'll explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 197 of Java for Tester series. That is the difference between throw and throws keyword. So throw versus throws. So what is throw keyword and what is throws keyword? And what is the difference between this throw and throws keyword in Java? So this is basically asked in the interviews, guys. Okay, in the interviews, Java interviews, if you attend, they will ask you what's the difference between this throw and throws. So guys, I already explained about this throw keyword in the previous one of the previous videos. I already covered what is this throw keyword and what actually its purpose is. Similar manner, I also explained what is this throws keyword and what is the purpose. So I covered this throw and throws keyword in one of the previous videos. Okay. So in this video session, I'm going to give you the differences between this throw and throws keyword. Okay. So before I give you the differences between this throw and throws keyword, I have to say that this throw and throws keyword are related to the topic known as exceptions. Okay. So both this throw and throws keyword belong to this topic of exceptions. So what actually this throw keyword does? Okay, at a high level, the purpose of this throw keyword is to manually throw an exception. If you want to manually throw an exception, okay, instead of Java throwing an exception based on the situations that occur while writing the Java program, Instead, if you want to throw an exception based on some condition, based on some your own condition, then we have to use this throw keyword. Okay, using this throw keyword, we can manually throw an exception. Whatever the exception we want to throw, we can throw manually using this throw keyword based on some condition. Okay, based on some condition, we can throw an exception manually using this throw keyword. But coming to the throws keyword, okay, the purpose of this throws keyword is to ignore the checked exceptions. Okay, so let me practically show you how to use this throw keyword and how to use this throws keyword and how they serve different purposes in Java. Okay, let's start with the first one, that is throw keyword for manually throwing an exception based on some condition. I'll directly write the program, guys. That is, let's say int age is equal to some 5. If I say if age is less than 6, okay, if age is less than 6, then I'll say throw new exception. Throw new exception stating age is less than 6, like this. Okay, if I want to manually throw an exception, okay, if I have to manually throw an exception, I have to use throws keyword. Okay, throw keyword or the mouse add throw declaration for now. Okay, so run this, right click, run as Java application. You see the exception will be manually thrown. Here, whatever the exception you want with a particular message, you can throw it. Okay, I already explained this throw keyword in one of the previous videos, guys. You can refer to this for more details. Okay, so here I'm only focusing on the difference between the throw and throws. Okay, throw is for manually throwing an exception like this based on some condition. If the age is less than 6, I am throwing the exception. Okay, I am throwing the exception only when the age is less than 6. Otherwise, if the age is greater than 6, okay, then I'll say that age is accepted. Age is accepted. Okay, some simple program I'm writing here. If I give 5 here, I'm going to get an exception, guys. Okay, right click, run as Java application. I'm going to get an exception. If the age is less than 6, I'm throwing the exception manually based on this condition. But if the age is something like 10, okay, the age here is going to be greater than 6. So here age is accepted will be printed. Let's run this. This time you'll not get an exception. You see, the exception is manual exception is not thrown. Okay, because this condition has not been satisfied here. Okay, to throw this particular exception. So like this, guys, while you are writing some Java programs based on some condition, if you want to throw an exception, you have to use throw keyword. Okay, based on some condition, if you want to throw an exception, you have to use throw keyword. But coming to the other one, that is throws keyword, we have to use this for ignoring the checked exceptions. Okay, I will write some code. Okay, so that is throw, so not throw, sorry. There is some code in Java, guys, thread dot, let's say sleep. Okay, I'll explain about this thread dot sleep in the upcoming videos. Okay, for now, just ignore this thread dot sleep and all. Okay, I'm giving something like 5,000, some 5,000 milliseconds. Okay, when I write this statement, Java compiler is giving you an exception saying that checked exception it is giving, guys. It's saying that Java compiler is giving you or telling you that there is a possibility of getting a checked exception here. That checked exception is nothing but this interrupted exception. Okay, either you have to handle it or you have to ignore it, guys. Okay, using this throws keyword, we can ignore it. You have to simply write down throws. Okay, what kind of exception it is giving? Let's remove this for now. Interrupted exception, right? Interrupted exception. Okay, I'm copying this. Now I'm adding here throws. If I have to ignore that compiler error message here for handling the exception, I have to simply write throws, paste it here. Okay, sorry. Throws interrupted exception, I guess. Okay, so interrupted, not this one. I'll cut this. Control X over the mouse. Interrupted exception, double R. Like this, you have to say like this, guys. Public static void main throws interrupted exception. Okay, thread dot sleep. Fine. So here, using this throws keyword, what we have done, we have ignored the checked exception specified by the compiler. Okay, that's the purpose of the throws keyword in Java. Okay, coming to the throw keyword, it can be used for manually throwing an exception based on some satisfied condition. But coming to the throws, it is used for ignoring the checked exceptions mentioned by the compiler. Okay, before running, the compiler will mention you the possible checked exceptions. Okay, so in order to ignore such kind of exceptions or compiler errors, you have to use this throws keyword. Okay, and mention the exception type. Then the compiler error will be ignored and you can run it directly. Okay, fine. So that's the difference between the throw and throws keyword in Java, guys. They are for different purposes, but they both belong to the exception category in Java. Okay, they both deal with the exceptions. So, but they have the different purposes. Fine. So that's it, guys. In the next video session, I'll explain about finally. Okay. So we can use this finally with the try catch blocks. Finally is another block which can be used with the try catch block statements. Okay. So how to use this finally block and what is the purpose of this finally block? I'll explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 198 of Java for Tester series. That is finally. So what is finally? Finally is a block. Finally is nothing but a block. It is a block. It looks something like this. Finally, like this. Okay. Finally is nothing but a block, guys. It looks something like that. It has some starting curly brace and ending curly brace. So how to use finally then? How to use finally? How to use finally block? Finally block has to be used with something known as try catch blocks. Okay. We have to use finally blocks with we have to use this finally block with try catch blocks. Okay, how to use finally block with try catch block? Let me show you. So try block will look something like this. We have to use catch block along with the try block. Exception E. This is the catch block, and along with this try catch block, we can use finally like this. Okay. So finally block. Finally is nothing but a block, and it has to be used with try catch blocks. Okay. Finally is nothing but a block, and it has to be used with try catch blocks. Fine. So what actually this finally block does? Okay. When you use this finally block with try catch blocks, what will happen? So guys, there may be some situations where, okay, some statement will be there here, some piece of code will be there here, right? This statement may or may not result in an exception. Okay, the statement inside this try block may or may not result in an exception. If an exception is coming, what will happen, guys? If an exception is triggered by this statement inside the try block, this catch block will be invoked, right? If there is an exception in the statement of the try block, the catch block will be invoked and executed. What if there is no exception triggered by this statement? In that case, this catch block will be skipped, right? This is what is going to happen in real time. But if you use finally, what will happen is, irrespective of whether this catch block is getting executed or not, okay, irrespective of whether this catch block is executed or not, this finally block will be executed. Okay, finally block will always be executed, okay. Here the catch block will be executed only when there is an exception in this try block statement, right? The catch block will be executed only when there is an exception triggered by one of the statements in the try block. Otherwise, this catch block will not be executed. But coming to the finally block, irrespective of whether we get an exception or not in the try block, this finally block is going to be executed. Okay, this is how finally block is different from the catch block. And when used with try catch blocks, this finally block will be executed every time, irrespective of whether there is an exception or not. This finally block will be executed every time. So let me practically demonstrate how to use finally block with this try catch blocks in Java. Okay. So guys, we have a Java project and we have this sample class and main method here. And inside this, I'm going to write down the try catch finally blocks. Fine. So let's write it. So int a is equal to sum 10, b is equal to sum 6. Okay. Now I am going to write some statement like int c is equal to a by b. Okay, int c is equal to a by b. Finally, system.out.println, the value stored, otherwise I will say the end of the program. Okay, I'll write some statement, the end of the program. Fine. Now guys, if this value of b is 6, there's no problem. 10 divided by 6, nothing, there's no problem. But what if I give this value of b as 0? In that case, 10 by 0 will give an exception here. So to make sure that the exception is handled properly, I will surround this particular statement inside the try block. Okay. There are two possibilities. I can change the value of b here. Let's assume that I can change the value of b here. Okay. I can give any value. Either I can give 5, 6 or anything, or 0 also I can give. Okay. So if I give 0, this will result in an arithmetic exception, as we already know. Okay. Here catch block will be there. Catch exception E. Here I will say system.out.println inside catch block I will say. Okay. Exception got handled and inside catch block. Exception got handled inside catch block. Here I will write, before this statement gets executed, I'll write system.out.println inside try block. Okay. Inside try block. After that, this particular statement will be executed. Then catch block. Here I will use another block known as finally. Along with this try catch block, I'm going to use finally block, guys. Okay. If you want, you can give spaces also, guys. There's no problem. Okay. Like this, you can give spaces. To make it look good, we can give some spaces. Fine. And finally, I will write system.out.println. This block will be executed irrespective of any exception in try block. This which block? This finally block will be executed irrespective of any exception in the try block. Okay. Then after that, after all this thing, this end of the program will be printed. Fine. So guys, let's run this. Let's run this and see what will happen. Right click, run as Java application. Before running, just let me tell you here, C is equal to A by B, 10 by 5. Okay. This will not result in any exception. Okay. Here, no exception will come. There is no exception going to be triggered out of this statement. What if there is no exception? If there is no exception in the try block, this catch block will be skipped, guys. Simply the catch block will be skipped. Will the finally block will also be skipped? The answer is no. Okay. Even though there is an exception or no exception in the try block, this finally block will be executed at any cost. Okay. Irrespective of the exception displayed in try or try block. Okay. Irrespective of whether the exception is coming or not in the try block. Okay. The finally block will be executed at any cost. So let's run this and see whether that is happening or so. Inside try block first. Okay. We went inside the try block. Then this particular statement got executed and there is no exception resulting out of this particular statement. Hence catch block will be skipped. As you can see, exception got handled is not printed here. That means catch block got skipped. And finally, block got executed, guys. This finally block will be executed irrespective of any exception in the try block. That means this finally block got executed irrespective of the exception in the, there's no exception in the try block, still the finally block got executed. Okay, but catch block got skipped. And at the end of the program got printed. That's fine. What if there is an exception? What if I give the value of b as 0? What will happen this time? Will the finally block be executed or not? Here we get an exception, right? This statement will result in an arithmetic exception because the value of b is 0 and a is 10. If you are trying to divide any particular number by 0 in Java, it will give you arithmetic exception. So we are going to, this is an exception, guys. Okay, this is an exception. We are going to get an exception, guys. Okay, in this statement. Since the exception is coming in this try block, the catch block will be executed. Okay, exception got handled, inside catch block will be printed. Will finally block will also be executed or not? Yes, it will be still be executed, guys. Okay, in case of exception in the try block also, this finally block will be executed. Okay, so let's see whether that is happening as I explained or not. Right click, run as Java application. First inside try block, and the statement has resulted in an arithmetic exception and it has invoked the catch block. The statement inside the catch block got executed, exception got handled inside catch block got printed here. Then finally will also be executed. Final block will be executed irrespective of any exception inside try block. Okay, and the end of the program. So guys, hope you understood now how this finally block works. Along with the try catch block, if you use finally, whether we get an exception in the try block or not, this finally block will be executed, guys. Okay, it will always be executed. That's how the finally block works in Java. But what is the purpose, guys? Why we have to use finally? Okay, what is the purpose? Why we want such kind of block of code which actually execute every time, irrespective of the getting exception or not getting an exception? This finally is getting final block is getting executed. So why such kind of block exists in Java? Okay, what's the purpose of this finally block? Okay, so generally this finally block is used to clear or close the instances. Okay, suppose you create some object for something. Okay, if you create some object for one of the class in Java, then in finally we generally use that finally block to close that particular object. Okay, clear the memory allocated to for that object. Once the task is done, the memory, the object memory space will be stayed like that only. Okay, the object memory space will stay like that only for a long period of time. Instead of that thing happening, as a good practice of coding, what we generally do is, okay, if you instantiate an object for one of the predefined class in Java, you can close it. Okay, for few of the predefined classes, we can close them. Let me show you with one example, guys. Okay, so let me clear out all this stuff. I'll write this program, guys. Based on this, you will understand the purpose of the finally block. File is equal to new file. Okay, and import this file predefined class. And here, let me give the path of this file. So let's say there is a one file abc.txt file in this particular location in my system. You can have any other file in your machine also if you want to try this out. abc.txt is the file. Okay. Now, what I'll do is file reader fr is equal to new. Sorry, I'll write something like this. File reader fr is equal to new file reader. Okay, like this I'll write. And to this, I have to import this file reader first. Import this file reader predefined class from java.io package. After that is done, I have to provide this particular file as an input to this file reader constructor. Okay. Furthermore, still an exception is still an compiler error is coming. It's saying unhandled exception, checked exception is coming. Okay. So I would prefer surrounding this particular statement with try catch block statement. Surround with try catch. Okay. File reader fr is equal to new file reader. Okay. If there is an exception here, it will print this print stack trace. Now to this, along with this, what I will do is I will add something like this. Finally, okay, this fr. Here you see new file reader means an object got created, guys. Okay, in the computer memory, an object got created for this file reader class, and some memory is allocated for this, right? Some memory is allocated for this. So once we are done with the program, we want to close that particular memory. Okay, so we want to clear out that memory or close the object created for this file reader class. So for that, there's a command known as fr dot. But I am not able to use fr because the scope of this fr is up to this try block only. Okay, I have to make this fr a bit outside the try catch block. So I will take this outside. Okay, so here I will not define again fr. File reader fr is equal to fr is equal to new file. Now I can access fr, guys. Okay, inside the final also I can access the object reference of this file reader. You see there is a close command. This close command will clear the memory allocated for this object of this file reader class. Okay, once the task is done, we are closing the memory simply. Okay, we are clearing or closing the memory. So I'm not going to handle this exception. Instead, I'm going to say add throws declaration for now to ignore this particular exception. Still, I'm getting an error, guys. We have to initialize the variable. Okay, here file reader fr is kind of not initialized. Okay, I have to initialize it. It's giving me the error saying that you have to initialize. If you select this, is equal to null will be added. Okay, you can manually also add. Okay, fr is equal to null. You can have to add to initialize this fr. Fine. So things are good. Fine. So there's a problem also coming, guys. Okay, I'll tell you that later. For now, just understand it at a high level, right? Just understand it at a high level for now. That is inside the try block, we have this fr is equal to new file reader. Okay, this particular statement may or may not result in an exception. Okay, if the file path of this particular file is correct. Okay, if it exists, okay, if this particular file path really exists, of this particular file really exists, then this particular statement is not going to give any exception. Since the path given is correct here, in this particular case no exception is going to be triggered. Okay, no exception is going to come. So run it, right click, run as Java application. You see no exception will come, guys. Nothing got printed because I have to add something here. I will system.out.println. I will say inside try block. I will say here I will say system.out.println inside catch block. Here I will say system.out.println inside finally block. So just get some output in the output when I run this program. I'm just adding these print statements. Right click, run as Java application. So first inside try block. Since there is no exception here, catch block got skipped, but finally will be executed at any cost. So inside finally block. What's happening here is the object created for this file, new file reader is closed here, guys. Okay. The object created for this file reader is closed here. So this is a good practice, guys. In programming, it's a good practice to close the objects. Once you are done with the task, you have to close the objects of this particular classes for which you have created the objects. Okay. So for that, finally block is suitable. That's the reason we have to, that's the purpose of the finally block is to close the objects created for the one of the predefined classes in Java. Okay. We can use finally block. Fine. Since the finally block will be every time executed, we can rely on it because at any cost, it's going to close the object. What if there is an exception coming here? That means I am just changing the file path here. I'll say XYZ. So here file path is not correct. So file reader will result in an exception. Okay. When exception is coming, what happened, guys? The catch block will be invoked. The first thing is that catch block will be invoked. If the exception is thrown, the catch block will be invoked and this particular inside catch block will be, I'll remove this. I'll say exception got handled. Inside catch block. Okay, inside catch block I'll write. So even after the exception is coming, still the finally block will be executed, guys. Catch block will be executed at same time. Finally block will also be executed. So in this case, what will happen, guys? Since the exception is coming here, the catch block will be invoked, and the statement exception got handled inside catch block will be printed. Then coming to the finally block, okay, inside finally block will be printed, but here another exception will come, guys. FR.close, because this FR is null. Since there is an exception in this try block, this object has not been created and assigned to this, but you are trying to close it. Okay. So to overcome such kind of problem, guys, let me show you that whether the exception is coming or not. Once the exception is coming, I'll show you the code for resolving that. Okay. So right click, run as Java application. Inside try block first. Okay. First inside try block got printed. Then the exception has been thrown from this file reader second statement inside the try block. Once the exception is thrown, the catch block got invoked. And inside catch block, we have this statement exception got handled, inside catch block got printed. That's fine. And finally, inside finally block, we also went to the finally block. But by the time when we are when this fr.close is getting executed, it has resulted in some null point exception because you are trying to close an object which doesn't have any object itself. The reason here is initially file reader fr is equal to null is set to null, no object. Fr is not set to any object in the memory, right? But here, when the exception occurred, this statement has not executed properly. Okay, exception has been thrown. Nothing has been assigned to this fr. That means still null is there to this null is assigned still to the fr. Since null is assigned to this fr and you are trying to close, you are going to get an exception like null pointer kind of exception you are going to get. To overcome that problem, what we have to do is we have to keep a condition here. If fr is not equal to null, if fr is not equal to null, then only close the object reference. Okay, close the object or clear the memory allocated to the object in the computer memory. Otherwise, don't clear. Okay, if fr is still null, there is no need of fr.close, right? So that's the condition I kept here. Okay, so if I run this time the exception will be cleared it out. Inside try block, exception got handled. That is catch block got invoked because the exception has come here. This got executed. Once the catch block is executed, finally has come. Then inside finally block got executed. Since fr is still null, fr.close will not get executed. Okay. But if there is no exception, in that case, guys, this finally block will close the fr. Okay. Close the object memory allocated to this fr. Okay. If not, the finally will be executed, but this will not be closed. Okay, something like this. So like this, guys, you can actually write this kind of programs in Java where you can use finally block, which will actually be executed irrespective of whether the exception is thrown here or not. Okay, at any cost, we are now clear that this object for the FR will be closed. Okay, at any cost, this is going to happen because finally block is going to be executed irrespective of whether there is an exception or not in the try block. Okay, fine. So this is how, guys, we have to use finally block in Java, which can be used with try catch blocks, and it will be executed every time, irrespective of whether there is an exception in the try block or not. Coming to the catch block, it will only be coming to the catch block, it will be only executed when there is an exception in the try block. But coming to the finally, irrespective of whether there is an exception in the try block, the finally block will be executed. Okay. So that's it, guys. In the next video session, I'll explain the difference between the final and finally. Okay, the final versus finally, I'll be explaining in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 199 of Java for Tester series, that is final versus finally. So what is the difference between final and finally? Okay, though they sound same, final and finally sound same, almost sound same, but they are different, guys. Okay, in Java, final is used for some purpose and finally used for some other purpose. At high level, final is a non-access modifier. Non-access modifier. Okay, as part of modifiers, I already explained this final in one of the previous videos. And coming to finally, it's not a modifier, guys. It's instead is a block. Finally is a block. Okay, finally is a block. So where to use this final? Final non-access modifier need to be used with variables, methods, and classes in Java. We can use this final non-access modifier with variables, methods, and classes in Java. And coming to finally, it has to be used with finally is a block, and it has to be used with try catch blocks. Okay, try catch like this. Okay, finally. Finally is a block in Java, and it can be used with try catch blocks in Java. Okay. And coming to final, final is a non-access modifier, and it can be used with variables, methods, and classes. What will happen when you use this final non-access modifier with variables? When this final non-access modifier is used with variables, okay, variables can be initialized or assigned only once. Okay, when you specify this final non-access modifier with variables, they can be only assigned with a value once. Only once it is possible to assign a value to this particular type of variables. Okay, they can be initialized or assigned with a value only once, such variables specified with final non-access modifier. Coming to methods, what will happen to methods when I provide this final or specify this final non-access modifier with methods? Okay, methods when specified with final non-access modifiers cannot be overridden. Okay, so you cannot create the same method, that is method having the same name or same method inside the child class, right? If there is a method in the parent class, you cannot create a duplicate of that particular in the child class if the method in the parent class is specified with final non-access modifier. That's the reason we can say methods cannot be overridden if you specify them as final. Last one, what will happen if you mention this final non-access modifier with classes? If you mention this final or specify this final non-access modifier with classes, you cannot inherit, okay, from that particular classes. That is, you cannot create child classes. For the classes which are specified with final non-access modifier, you cannot create any child classes. Okay. Anyhow, I already explained how to use this final non-access modifier as per one of the previous videos. You can refer to one of the previous videos, guys, where in this series I explained in detail about this final non-access modifier. And coming to the finally block, okay, finally is a block, and it has to be used with try catch blocks. And this finally block will get executed always, okay, irrespective of whether we get an exception in the try block or we don't get an exception in the try block. Okay, this finally block will be executed at any cost. Okay, but coming to catch block, it can only be executed when there is an exception. Otherwise, the catch block will be skipped from execution. But coming to finally block, irrespective of whether we have an exception coming in the try block or we don't have an exception coming in the try block, the finally block will be executed at any cost. That is, it's always executed. Okay, that's the purpose of the finally, guys. Okay, generally use it to close the objects. Okay, generally use it to close the object instances and all those stuff. Okay, but coming to the final, it has to be used with variables, methods, and classes to modify their behavior. Like variables, when used, can be only initialized once. Methods cannot be overridden, and classes, you cannot create child classes. So guys, final and finally are different in Java. They are used for different purposes. One is a non-access modifier, another one is a block which can be used with try-catch blocks in Java. Okay. So guys, it's all about the final versus finally. In the next video session, I'll explain what will happen or what are the consequences of getting an exception in try-catch block. Okay. So if you get an exception in try block, what will actually happen? What are the consequences that we have to face as part of getting an exception in the try block? Okay. So that thing I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 200 of Java for Tester series, that is statements execution in try block. Let's say, guys, there is a try block. Okay, we generally have these try catch blocks like this, right? Actually, like this, we have these try catch blocks in our programs. And in the try block, let's say there are few statements. Statement 1, then we have statement 2, and then statement 3, and so on. Okay, let's say for now, let's say there are some 3 statements inside this try block, and associatedly we have this catch block. Okay, now guys, let's say the exception has occurred at this statement 1. Exception occurred here. What will happen, guys? What will happen when this first statement inside this try block has resulted in an exception? What are the consequences here? Consequences nothing but the statement and statement 2 and statement 3 won't be executed. Okay, this both the statements, that is statement 2 and statement 3, which are coming after the execution, that is exception, won't be executed because inside this try block, though we have multiple statements, the first statements we got this exception. Because we got the exception in the first statement itself, okay, the control will go from, okay, the control will go from here to here. We directly go to the catch block, okay, without, by skipping the statement 2 and statement 3, which are followed by the statement which is throwing an exception, okay, the control will go to the catch block. When an exception occurs in the statement 1, that means the execution inside this try block will stop there itself, okay, and it will immediately move to the catch block. So the following statements will not be executed. What if we got the, what if we got the exception in the step 2, that is statement 2? We got exception here. Exception occurred here, let's say. In this case, what will happen here is the statement 1 will be executed, okay? While executing the statement 2, okay, while executing the statement 2, the exception occurred. So the execution of the code inside this try block will stop in the statement 2 itself, and it will immediately move to the jump to the catch block. The statement 3 won't be executed, okay, it will not be executed because the exception has occurred in the statement 2. Okay, what if we got the exception in the statement 3 itself? There's no problem because there are no other statements after statement 3. Okay, all the statements in the try block will be executed. So in simple terms, guys, in simple times, if we get an exception in this particular statement inside the try block, if we have multiple statements and if we got an exception here, all the other below statements which are followed by that exception throwing statement will not be executed. Okay, all the statements won't be executed. Okay, so guys, let me practically demonstrate that for you. Fine. I'll write some try block here. Inside this try block, I will write some statements. Let's say this is the first statement. I will say before exception in try block. Then here I will write a statement which actually throws an exception. Say int a is equal to 10 divided by 0. What kind of exception does this particular statement will throw, guys? It will throw an arithmetic exception, right? Second statement inside the try block is going to throw an exception. That is an arithmetic exception. And here I'm going to write a statement after exception in try block. Then here we are going to have a catch block. Exception is okay. System.out.println inside catch block. Okay, inside catch block. Like this, we have this try catch blocks. So when I run this program, what will happen, guys? Can you guess what will happen when I run this program? Simple, guys. When you run this program, we'll go inside the try block and this first statement will be executed. That is before exception in try block will be printed in the output. After that, this particular statement will be executed. That is second statement inside this try block where arithmetic exception will be thrown. Okay, this exception will be thrown by this statement. When the exception is thrown here, all the other statements will be skipped. Okay, this particular statement will not be executed. When you got an exception, immediately the controller will move to the catch block. Okay, from the second statement, we are moving to the catch block. Without executing this third statement, we are directly moving to the catch block. And finally, inside catch block will be executed. That is before exception and try block. Then we got an exception. Then inside catch block will be printed. Okay, let's run this and see whether that is happening or not. Okay, you see before exception and try block. Then here we got an exception. This particular statement got skipped. And finally, we moved to the catch block and inside catch block got printed here. Okay. What if we didn't get an exception here? What will happen in this case? This will be executed. This will also be executed. There will not be any exception. Since there is no exception here, the statement following that particular statement will also be executed. That is after exception in try block will be printed. And since there is no exception in the try block, catch block will be skipped. Right click run as Java application. So before exception in try block, after exception in try block. Here we need to understand one thing, guys. If you are going to get an exception in one of the statements, all the statement inside the try block, if you are going to get an exception in one of the statements, all the statements following that particular exception throwing statement will not be executed. Okay. Here when I say 10 by 0, this particular statement will not be executed, guys, because this particular statement is going to throw an arithmetic exception. Okay. So guys, that's about the statement execution in try block. Okay. What will happen when you get an exception in one of the previous steps in the try block? Okay. All the steps following that exception step in the try block will not be executed. Okay. So that's the thing. So that's it, guys. In the next video session, I'll explain about interfaces. I'll explain about the interfaces. See you in the next video session, guys. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 201 of Java for Tester series, that is interfaces. So what are interfaces? So in order to understand the interfaces, you need to understand few things about interface first. Okay, I cannot directly explain you about interfaces sign. I cannot tell you that this is what is interface in the beginning itself. Instead, to make you understand what exactly the interfaces are, let me explain this interfaces related things in a step-by-step manner. Later, once you understand all those things, you will be able to understand what exactly the interfaces are. So guys, let's get started with the things. Okay, I'm going to explain in a step-by-step manner about this interfaces. So to start with, the first thing that you need to understand about interfaces is interfaces look similar to classes. Okay, interfaces look similar to classes. So how come? So let me practically show you. Okay, how interfaces look similar to classes. Let me practically show you. Fine. So here is a Java project. Right click on this SRC and select new. How to create a class, guys. Okay, in the Java project, how to create a class. In all the previous videos, I explained you how to create a class, right? So let's create a class. Right click on SRC, select new, and we have to select class. So it will ask for the class name. You can give any class name. I'll give some class name like class 1. Click on finish. So the class got created. The class got created. Public class name. Okay. So how the class looks like? Public access modifier. Public is the access modifier that's specified before the class. and this is the class keyword which is used for creating the class. Okay, this class, using this class keyword, we are able to create a class with the name class1. Okay, so, and this is the starting of the class, this is the ending of the class. This is how the class looks like. But if I compare this class with the interface, it all almost looks similar. Okay, only here class is there in interface. Instead of class, the interface will be there. Other than that, the class and interface look almost similar. So let me show you how the class looks similar to the interface. So right click, select new, and instead of selecting this class, you have to select the interface. Okay, so here, let me give some sample name, say interface 1. You can give any name here and click on finish. Observe that the interface got created. Okay, you see, even the interface also looks similar to the class, public class name. Here, public interface name. Here, starting of the class, here, starting of the interface. Here, ending of the class, here, ending of the interface. Almost all the class and interface looks almost similar, guys. Only the difference between this class and interface is that here, in order to create a class, we have to use a keyword known as class, right? But in order to create an interface, we have to use a keyword known as interface. That's the only difference, guys. But classes look, or interfaces look similar to the classes. Okay, there will not be that much difference other than the keyword used for creating the classes or interfaces. Okay, fine. So coming to the next thing that you need to know for understanding the interfaces better is interfaces are the extensions of the abstract classes. Okay, interfaces are the extension of the abstract classes. So how can I say that the interfaces are the extension of the abstract classes? Okay, fine. Let me show you. So on the left side, I will write down something like abstract class. On the right side, I'll write something like interface. Okay, I'm saying that interfaces are the extensions of the, okay, or the extension. That is the next level. You can say extension means here interface is the next level of the abstract class. Whatever the abstract class does, okay, whatever the abstract class does partially, that particular thing, the interface does it fully. Okay, here partial thing will be done by abstract classes. That thing is fully done by this interface. So what is that thing that is partially implemented by abstract classes and fully implemented by the interface? Okay, so if you understand that thing, you will be able to understand how the interfaces are the extension of the abstract classes. Okay, so guys, if you remember, in one of the previous videos, I explained about this abstract. Okay, abstract is a non-access modifier in Java. Okay, in one of the previous videos, I explained about this abstract non-access modifier, and also I explained you what will happen when you specify this abstract non-access modifier before classes, right? So let me recap you at a high level. So guys, so it will look something like this: public abstract. Okay, if I create some class like this, okay, public abstract class, some class name, say class1. Okay, let's create a class like this: public abstract class name. Okay, so this is wrong. Public abstract class name, starting of the class and ending of the class. Here abstract is a non-access modifier specified before the class to make this particular class an abstract class. Fine. So inside this abstract class, if we have to create some methods, okay, let's say public void some method A. Okay, if I have to create this method, can I provide the body, guys? Okay, yes, you can provide the body. That's not a problem. Okay, so body can be provided. Inside the abstract class, the methods can have the body. Same time, abstract classes can have some abstract methods. Public abstract void method B, let's say. Okay, here guys, this particular abstract method doesn't have any body. Okay, if you specify this abstract non-access modifier with the methods, you cannot create a body for that, guys. You cannot specify a body. If you try to do so, you'll get a compiler error. But here, this other method, that is method A, doesn't have this abstract keyword, so you can specify the body. You can write any statement inside this, the body of this particular method A also. Okay, So here, the conclusion here is, whatever that I want to explain here is, abstract classes can have both abstract methods and non-abstract methods. Okay, it's not completely abstract. Abstract classes are not completely abstract. Okay, you can have few methods. You can actually create body for. Okay, you can actually implement. You can say you can implement some methods and you can make other methods as abstract. Okay, that's how the abstract classes can be. But coming to the interfaces, guys, if you create some interface, public interface, some, so you don't have to specify abstract keyword here. Interface itself is an interface. Okay. So let's say interface one is the interface name and starting of the interface and ending of the interface. So here, what is the difference between these abstract classes and interfaces? In abstract classes, you can have both implemented methods and unimplemented abstract methods. But coming to the interfaces, all the methods should be of abstract type only. By default, they're abstract guys. Okay. So method A, you cannot create body for these methods. Okay, you cannot provide the body for these methods. All the methods inside the interfaces are of without body itself. Okay, they are by default abstract. You don't even have to specify the abstract keyword here. I don't have to specify abstract keyword here. That's not required. Okay, by default, all the methods inside the interface are of abstract type by default. You cannot have or specify the body for the methods inside the interface. But coming to the abstract classes, you can have both type of methods, guys. One method can be abstract, another method can have some body and its implementation. Okay, that's why I say interfaces are the extensions of the abstract classes. Okay, that means here partial implementation of the abstraction is there. Okay, here partial abstraction is there. Okay, few methods are abstract, other methods are not abstract. So partial abstraction is there here. But coming to the interfaces, 100% full abstraction is required. Okay, mandatory. If you try to create some body for this methods, you are going to get a compiler error. Okay, so let me show you practically, guys. Okay, I'll first show you the abstract classes and how you can create methods without body and with body. And coming to the interfaces, I will show you how you can only create the methods without any body. If you try to create a method with body, you will get some compiler errors in case of the interfaces. But in case of abstract classes, you can have both type of methods. But in interfaces, all the methods should be of abstract type by default. You cannot have the body for any of the methods inside the interface. That's why we say interfaces are the extensions of the abstract classes. They fully implement the abstraction with respect to the methods. Okay, let me show you practically. Fine. So already we have some examples here. Okay, so let's add something like abstract. I'm just making this class an abstract. So inside this abstract class, I can have both abstract methods and non-abstract methods. Okay, let's create that. Public void some method A. You see, I'm not getting any compiler. I can create the method body. I can even write some statements inside this method A, system.out.println. Okay, inside some method A. Okay, like this. Okay, inside the abstract classes, you can have non-abstract methods. The methods which have the body, you can have. At the same time, you can have abstract methods also. Abstract void, public abstract void method B. So if you try to create a body, you will not be able to, because this particular method is specified with abstract. So it should not have any body. So it should end something like this. Okay. So this particular method is of abstract type and it doesn't have any body. So abstract classes can have both non-abstract methods and abstract methods without body. Okay. Fine. Coming to the interfaces, you don't have to specify anything, guys. If you try to create any method like this, public void some method A, if I try to create method A and try to provide a body, you see immediately you are getting the compiler. I didn't specify anything as abstract. By default, these methods are abstract, guys. Okay. Internally, these methods are abstract type. You don't have to specifically specify the abstract here. Okay. You cannot have the body, guys. Abstract methods do not specify a body. You see, by default, the methods inside the interface are abstract by default. Okay. Even though you don't specify, they are abstract. Fine. You see, when I don't create any body for these methods, you see, it's accepted. So all the methods should be of abstract type by default, guys. Okay, you cannot specify the body. If you try to do so, you are going to get the compiler error. Public void some method C. No matter how many methods you create, all the methods should be of abstract type. Without the body, it should be there. By default, they are abstract type. So that's why we say the interfaces are the extensions of the abstract classes in Java. So you understood two things here about interfaces. First thing about the interfaces that you understood here is interfaces look similar to the classes. Okay. And second thing that you understood about the interfaces is interfaces are the extension of the abstract classes. All the methods inside the interfaces are abstract by default, whereas in the methods, few methods can be abstract, few methods can be non-abstract. Okay, that's second thing about the interfaces. Now let's move to the third one. Okay, what is the third thing? Let's find it out. So what is the purpose then? Okay, why interfaces have full abstraction? What is the purpose? Okay, so let me explain. So here I am saying the purpose of the interface is to provide a common behavior that can be used by several classes by implementing the interface. Okay, suppose guys, okay, you can either call it a common behavior. Okay, so I'm just going to explain the purpose, right? So let me explain first. Write down few keywords here so that you'll understand whatever I'm talking. Okay, purpose is common behavior. Okay, in order to share the common behavior, we have to use interfaces, or you can even treat it as a contract. Okay, interfaces can be treated as a contract kind of thing, which need to be followed. Okay, which need to be followed, or you can say norm kind of thing, rule or norm. Okay, a interface is a rule kind of thing. Okay, common rule to be followed by everyone. So, or what you call rule or standard, you can say. Okay, interface is like a standard to be followed. So let me take one example so that you will be able to understand whatever I'm talking here. Okay, interface is nothing but a common behavior that can be implemented by different classes. Before understanding that particular statement, you need to understand these keywords. What is why I'm saying interface is a common behavior? Why I'm saying the interface is a contract? Why I'm saying the interface is a norm or standard? Okay, all are same guys. Okay, here all these terms are same. Okay, you will understand all these keywords right now. For example, guys, there's some bank. Okay, there are different banks in India, right? For example, let's take different banks in India. Okay, let's take one bank like HDFC Bank, and other bank. Let's take another bank that is Axis Bank. I'm just talking about different banks in India, guys. Okay, I'm just taking Indian example for banks, and HDFC, Axis, something like ICICI. Okay, like this. There are different banks, let's say, and there are other banks also in India. Okay, so guys, so there in India there is some authority known as RBI, right? There's something known as RBI. Okay, what actually RBI does? What exactly the RBI does, and how this RBI is related to these banks? Okay, so let's find out. Okay, if you understand this concept, you will understand why I'm saying interface is a common behavior, contract, norm, or standard. Okay, so what RBI does for these banks is that RBI creates some rules. Okay, for the banks. RBI creates rules and takes decisions. Okay, creates a kind of rules or norms or whatever you say. Okay, the bank should be like this or like that. Okay, if you are a new person, for example, if you are entering into the banking sector, okay, you are a business person, and you want to establish a bank in India, let's say. Okay, so in order to create a bank, you cannot actually create with your own terms, right? So you have to follow some procedure, or you have to follow some standards or norms or whatever it is. Okay, so something should be in common between other banks and your bank. Such kind of thing you have to follow. So for that, let's say this RBI, okay, has defined some rules and has taken some decisions about the banks, and it has told everyone that whoever is entering into the banking business have to follow these rules, obey these rules. Okay, then only your bank will be approved and you will be able to run the banking business in India. Let's say. Okay. So for that, RBI has created this bank interface. Let's say this is an interface. Okay. I'm just connecting the real world thing into the programming thing, guys. Okay. So by using this, you will be able to understand interfaces better. Okay, let's say RBI, in order to make other banks follow these rules and regulations, RBI has created an interface known as bank. Let's assume this example. Okay, such thing is happening. Let's assume in the programming. Okay, so let me practically demonstrate. So let's delete these things. Let's create a bank interface. Okay, right click new. Sorry, I have to create an interface. Right click new. I have to select this interface. I'm naming this interface as bank, guys. Okay, click on finish. Public interface name, that is bank. So now assume that this bank interface is being created by RBI. Assume that this bank interface is being created by RBI to set some rules or norms or standards or contract kind of thing, which need to be followed by every bank in India, let's say. Okay. So for that, let's find out. Okay. So string account type. Okay. The RBI is defining some account types. What type of accounts are allowed in India? Let's say savings account. Okay. In any bank, in India, RBI wants you to create account type as savings type account. Another type of account is like account type business account, that is you can say current account. Okay, current account type 1, I will say account type 1, account type 2 here. Okay, like this we have two account types. Now the second thing is I'm creating some methods. Okay, inside the interface you cannot create a body for the methods. All the methods are by default abstract. Okay, only the design will be done by the bank interface. Implementation will not be done here. So let's create public void. Okay, public void adding, or we can say technically speaking you can say depositing money. Okay, deposit or deposit money, you can say deposit money. There's something like every bank should allow the users to deposit money. Okay, every bank should give the users an option to deposit the amount or money. And at the same time RBI wants every bank to implement this thing also, like every bank should allow the people to, or users of the bank to withdraw money. Okay, withdraw the money. And every bank in India should be able to transfer the money. Okay, transfer money to other accounts, or every bank should allow. Okay, every bank should in India should allow the people to open fixed deposits. Okay, open fixed deposits. Like this, lot of several things will be there in the bank. If I keep on writing, a lot of things will come, guys. Okay, open recurring deposit. Okay, public void open bank account. Okay, so public void close bank account. Then if you keep some money inside the bank will pay you some interest, right? Despite of being you open some fixed deposit, bank should pay some interest amount for the even the saving amount itself. Okay, if you don't even provide open the fixed deposit in India, okay, if you actually store some amount inside the bank should pay you the interest amount for the amount that you saved in the bank. Okay, so what we can say is calculate interest amount for savings. Whatever the savings you have in the bank, for that interest amount will be calculated here. Okay, so public void define interest rates. Okay, so define interest rates. Okay, for savings some interest rate should be there, for fixed deposit some interest rates should be there, all those things. Like this, lot of functions. Okay, now what you call whatever the operations that can be done by the bank. Okay, the kind of rules that need to be followed by every bank, the kind of norms or standards to be followed by every bank. Okay, are kind of created inside this interface bank. Okay, let's say by the people known as RBI. Okay, by the department known as RBI department has created an interface like bank here with all such kind of rules. There may be many, guys, but I am just for this example, this is enough. Okay, now guys, the turn comes to the different banks. Okay, so let's say there are different banks. Right click new class. For the banks, you just create the classes. Okay, so let's say HDFC Bank. HDFC Bank. Click on finish. And other bank I would like to create is like Axis Bank. Say Axis Bank. Another class I will create is like another ICICI Bank. Like this, there are different classes. Now what we have to do is all these banks, that is HDFC Bank, Axis Bank, ICICI Bank should follow this rules or norms or standards. Okay, how to do that? For that, guys, all these banks should implement this interface. Okay, should implement this. HDFC Bank should implement this bank interface. This Axis Bank should implement this bank interface. ICICI Bank should implement this bank interface. Okay, so let's say public class. For that, we have a keyword known as implements keyword, guys. Okay, in order to implement an interface, we have to use a keyword known as implements. HDFC Bank implements this bank interface. I have to say bank. Okay, so implements is the keyword. Public class name implements interface name. Okay, so what will happen when I do so? When I do so, you will get this compiler error saying that this particular HDFC Bank class must implement all the abstract methods of this bank interface. You see, all these rules should be followed by this HDFC Bank. Okay, so hover the mouse and select add unimplemented methods. Create something like this, guys. Okay, public void deposit money, public void withdraw money, public void transfer money. You see, all the things that you specified here, deposit, withdraw, transfer, everything has come up here. You have to implement them. Okay, this particular class implementing this interface should implement all these methods, abstract methods of the interface. Okay, all the abstract methods of the interface called bank should be implemented by this HDFC Bank. So here, coming to this example, RBI department has created this interface known as bank, and this bank interface should be implemented by all these banks in India. HDFC Bank should implement this bank interface. Axis Bank should implement this bank interface. ICICI Bank should implement this bank interface. Whenever, if and only if all these banks implement this interface, then only RBI will approve the running of this particular banks in India. Okay, such kind of situation. For that, you have created this different classes, and all these classes are now have to implement the bank. Okay, implements bank. Axis Bank implements. What's happening? Okay. Public class name. Okay. Okay. Let's say there is some spelling mistake here. Let me type it properly. Implements. Okay. Now it's good. So public class name implements bank. So this particular bank also should implement all the abstract methods of this interface. Okay, here design is there, contract is there, here standards are there, rules are there, norms are there, whatever you call. Okay, so you can call anything: standards, rules, contract, norms. Okay, common behavior to be implemented by all the classes. You can say anything. Over the mouse, add an implemented methods. Okay, here ICICI Bank also same thing. Implements bank. Okay, so hover the mouse, add unimplemented methods. All the unimplemented or abstract methods of the bank interface will be have to be implemented here. Here, HDFC Bank has to implement this method in its own way. Okay, deposit money. Okay, so developers will be writing, the HDFC Bank developers will be writing the code for like how the applications or process should be there for depositing the amount in the HDFC Bank. So HDFC own implementation for this deposit money will be there. We're coming to the Axis Bank. Axis Bank has its own way of depositing the money. So such kind of code will be written inside the deposit money, okay, of the Axis Bank. ICICI Bank also will have its own way of depositing the money. Okay, so such kind of logic should be written. Logic of the ICICI Bank way of depositing the money should be written inside this deposit money method. So every class will have to implement in its own way. Okay, in its own way. So, but this HDFC Bank, Axis Bank, and ICICI Bank should follow the rules, norms, or standards or common behavior of this bank, okay, which is set by this RBI Department of India. Okay, so guys, this is actually the interface. The purpose of the interface is to set the norms or standards or contract for the classes to be created. Okay, all the classes implementing this particular interface should follow the standards, norms, or contract. Here, guys, here only the design is being done. Okay, inside the interface we are not implementing anything. You see, if you go to this bank interface, are we implementing anything? No, we are just inside the bank interface, we are not implementing anything. Okay, This is just a design, abstract kind of design it is. Okay, implementation will be done by the classes which are implementing this interface. Okay, the classes which are implementing this interface have to implement the abstract methods of this interface. Only the design will be done here. Implementation will be done by the classes implementing the interface. Okay, so guys, at a high level, this is what exactly the interface is. Okay, so the interface is like a contract, norm, or standard that can be implemented by the implementing classes. Okay, implemented by the implementing classes. That's what exactly the interface is in Java. Okay, so guys, there are more things to be explained about this interface, guys. Okay, I just explained only 3 points in this session. I explained only 3 points about the interface. Not to make you understand the interface, I explained 3 points. That is, interfaces look similar to classes. Interfaces are the extension of the abstract classes. Okay, so, and third thing is like the purpose of the interface is to set the standard norms, contract, or common behavior across multiple classes which are implementing that interface. Okay, and there are more things to be explained about the interface, guys. I cannot take the entire session here. So what I'm doing is the upcoming videos, the next videos, the coming videos, I'm going to explain each and every feature of interface. Okay, in a step-by-step manner, you are going to learn interfaces in detail in this interfaces series of videos followed by this video. Okay, so guys, let's learn more about the interface in the next video session also. So that's it, guys. In the next video session, I'll explain the interfaces and the naming convention. Okay, how to name the interfaces in Java. That thing I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 202 of Java for Tester series. That is interfaces and naming convention. So how to name the interfaces? Interfaces and naming convention. So guys, in order to name the interfaces, we have to use something known as Pascal case. So what exactly is this Pascal case? So in order to understand the Pascal case, you need to understand two types of cases. That is, one we have is camel case, other one is a Pascal case. Okay, if you understand the difference between this camel case and Pascal case, then you will understand what exactly the Pascal case is. Okay, for example, you have to name something like this. Okay, you have to name something like class 1 kind of text. Okay, class 1, two words are there, class 1. Okay, if you have to represent this class 1, here we can divide this class 1 into two words. Class is one word and 1 is another word, right? If you have to represent this class 1 in camel case, you have to write something like this, camel or class 1. Okay, if you have to represent this class 1, which is of two words, in a camel case, you have to write class 1. Okay, as you can see in the camel case, the first letter will be small, and from second word onwards, okay, from second word onwards, the first letter of the second word will be capital. Okay, if you have something like this, 1, 2, 3. Okay, if you have multiple words inside the class name, okay, here C is starting with small letter, second word capital letter, first letter of the second word capital letter, first letter of the second word, third word capital letter, first letter of the fourth word is also capital. Okay, here O, T and T are in capital, but the first letter is a small letter. Okay, first word, first letter is small letter, remaining all words, first letters are capital letters. But coming to the Pascal case, okay, it's kind of different when compared to the camel case. That is, if I have to mention this class 1, 2, 3 in Pascal case, it will be like this, guys. Class 1, 2, 3. Okay, what's the difference, guys? Here, the first letter of the first word is small, but here in Pascal case, the first letter of the first word is in capital only. Second word, first letter is also capital letter. Third word, first letter is also capital. Fourth word, first letter is also capital. But coming to here, in camel case, we have the first word, first letter as a small, remaining all capital. But here, all the first letters of the words will be in capital letters. So that's the difference between the camel case and Pascal case, guys. And in order to represent the interfaces, not only interfaces, okay, but also classes. Okay, classes and interfaces. Classes and interfaces in Java has to be represented in Pascal case. Okay, classes and interfaces in Java need to be named with Pascal case. The naming convention for using this class and interface is Pascal case. So guys, let me practically show you. For example, if I create a class, right click new class. So class 1, we generally say class 1, 2, 3, for example, okay. So here multiple words are there in the class name and all the first letters of the words here are in capital letter. C, O, T, T are in capital letter, okay. The same thing for the interfaces also guys. Right click new interface and here interface 1, 2, 3. Let's say this is the name of the interface and you see all the first letters of the interface, all the first letters of the different words in the interface name are in capital letter. That means this is Pascal case guys, okay. We have to follow the Pascal case as part of the naming convention of this classes and interfaces in Java. So guys, that's it about the interfaces and the naming convention. In the next video session, I'll explain the next topic of interfaces, that is interfaces and the constructors. So that's it guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 203 of Java for tester series, that is interfaces and constructors. So guys, can we create constructors inside the interfaces? So can we create interface constructors inside the interfaces or not is the question. So answer for this question is no guys. Okay, we cannot create constructors inside the interfaces. It's not possible guys. Okay, you'll get the compiler error when you try to do so. So guys, let me compare two things here. So we have something like abstract classes in Java and we have interfaces in Java, right? So my question here is, can we create constructors inside the abstract classes? And can we create constructors inside the interfaces? Here, yes, we can create constructors inside the abstract classes, but we cannot create constructors inside the interfaces. It's not possible, okay? If we try to do so, we'll get compiler error, okay? Let me explain guys, okay? Let me explain practically that you can create constructors inside the abstract classes, but you cannot create constructors inside the interfaces. Okay. So let me create a interface. So let's give some interface name, interface demo, some name I gave for the interface. Click on finish. Inside this, I have to create a constructor, let's say, okay. So public void, the return type will not be there for the constructor. So only access modifier followed by the name of the interface, okay. So when you try to do so, you'll get a compiler error. Okay, constructors cannot be, interfaces cannot have constructors is the compiler error message, guys. Okay, as you can see here, you cannot create constructors inside the interface. Okay, if you try to do so, you will get a compiler error saying interfaces cannot have constructors. Fine. What if I create a class? Okay, can I create constructors inside the abstract classes? If I create some abstract class, let's say class demo. I'm just making this class an abstract class by adding this abstract non-access modifier before this class. So can I create constructors inside this abstract class? Yes, guys, we can create constructor for the abstract classes. Okay, constructor will not have any return type, so public and the name of the class. You try to do so, you see, you will not get any compiler error. We can create constructors inside the abstract classes in Java, but we cannot create constructors inside the interfaces in Java. So guys, coming to interfaces and constructors, constructors cannot be created in the interfaces. So that's it guys. That's all about the constructors and interfaces where constructors cannot be created inside the interfaces. The next video session, I'll explain about the interfaces and its variables. Okay, interfaces and its variables. So that's it guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 204 of Java for tester series, that is interfaces and variables. Interfaces and variables. So the first question here is, can we create variables inside the interfaces? Is a question. The answer is yes, guys. Yes, we can create the variables inside the interfaces. But the variables which are created inside the interfaces have some specific properties. That is, by default, the variables created inside the interfaces are of final, are of public, static, and final type. Okay. By default, the variables created inside the interfaces are of public, static, and final type. Okay. Even though you don't specify this public, static, and final before these variables created inside the interfaces, internally they are treated as public, static, and final by default. Okay. So for example, in the SRC, right click, say new. Okay. Let's create an interface. I will create an interface, say bank. Click on finish. The name of the interface here is bank. Inside this interface, I will create some variable. Okay, let's say I will create some variable like string account type 1 is equal to savings. Okay, some savings account. I created a variable here. Okay, I declared this with a string data string type and assigned some value to this. So did I mention anywhere for this particular variable? Did I mention anywhere like public, static, or final? No, right? But internally or by default, this variable is of public, static, and final type. Let me prove that. Okay, let me prove how this variable is kind of public, static, and final type by default internally. Even though I have to specify something like this, right? I can explicitly specify public. Even though if you don't specify also, it's public only, guys. Okay. Even though you don't specify a static, it's static. Okay. Even though you don't specify final here, it's a final. Okay. So the variables created inside the interfaces are by default public, static, and final type. Okay. So let me practically show you one by one. So to start with, I will explain about static. Okay. By default, this particular variable is static. Okay. By default, the variable created inside the interface is by default static type. Static non-access modifier is specified internally, even though you don't specify explicitly here, specified internally. So to prove that, generally guys, if you create some variable inside a class, okay, if you create some variable inside the class and specify that as static, how to access such kind of variables, guys? Okay, so as we already know, let's say there is a class here. This is not an interface, guys. Let's say there is a class here, some class 1. Inside this, you created a variable like this, int a is equal to some 5. Okay, static int a is equal to 5. So from another class, if you try to access this variable, okay, how to access? Okay, let's say there is some demo class with main method inside it. Okay, some main. Assume that I'm just writing at a high level, guys. Okay, don't treat this as a proper code. Fine. Inside the main method, I have to in order to access this variable a, which is of static type inside this class 1. How to access? Guys, as we already know, static variables belong to the class memory, right? Instance variable belong to the object memory, whereas static variables belong to the class memory. As explained in one of the previous videos, right? I explained this particular concept in one of the previous videos where I explained about static non-access modifier, right? The variable which is specified as static inside a class belong to which memory? Class memory, not object memory. Okay, it's a common memory known as class memory. So in order to access such kind of variables also, we have to say system dot out dot println. Okay, let's say, okay, how to access this variable, guys? We have to use the class name because this particular variable is of static, which belongs to the class memory. We have to use something like this. Class one dot a. I have to say, okay, class one dot a, because this variable belongs to the class memory because it's of static type. So in order to access this variable, we have to use the class name dot. Okay, so same thing if you use this static, okay, same thing in the interface. Okay, let's say this is an interface. So interface name, let's say bank is the interface here, and inside this I created a variable, right? String account underscore type 1 is equal to some savings I created. By default, the variables inside the interface are of which type? Static type. Okay, you don't have to explicitly say static. The variables created inside the interface are by default static. Okay, internally they are treated as static only. So since this particular variable is a static now, how this belongs to which memory? Interface memory or the instance memory? It belongs to the interface memory. Here bank is the interface and this variable is saved into the bank interface memory. So how to access? If you have such kind of main method, you can access in the same way, like bank dot account. What is the variable name? Account type 1 is a variable name. Okay, type 1, type underscore 1. Okay, bank dot account underscore type underscore 1. Okay, like this we have to access, because this one is by default static, because it's this particular variable inside the interface is internally or by default static. Not to access them, you have to use the interface name bank dot account type 1, like this. Okay, so guys, so let's find it out whether this is static or not by creating another class. Say I'll name this as demo class, and I will have this main method inside that. So I'll drag it this side so that you can see both the interface and class at the same time inside the main method. Okay, I'll try to access this. Okay, system.out.println. Okay, how to access this one, because this is of static type by default. You have to use the interface name here. Okay, bank dot account type 1, like this you have to access. Okay, static variables can be accessed using their class name or interface name. Okay, you don't have to create the object, you have to access them using the class name or interface name. Here in this case bank is an interface, you have to use the interface name dot the static variable. Okay, like this you can access. Fine, now it's clear that it is an static type. Okay, because we are able to access this particular variable using the interface name, so it's a static type. Okay, internally it's a static. Second thing is final. Okay, final means what is meant by final, guys? Once you specify this particular variable as final, the value cannot be changed. Once you initialize this particular value to this particular variable, here savings is assigned to this account type 1. What if I don't provide value also? You'll get an error, guys. You see, you're going to get a compiler error. The blank final field cannot, the blank final field account type 1 may not have been initialized. It's mandatory for you to initialize here in the interfaces, because Java knows that this particular variable is internally of final type. Okay, so you have to assign the value there itself. Okay, you have to assign the value, otherwise it will not allow you. Okay, because once you assign the value, this particular variable value cannot be changed. Let's try to change this particular value from this method. Say I will say how to access this variable bank dot, because this is of static type, I can access like this account type, and since it is of final type, you cannot change the value here. Okay, since this particular variable is of final type, you cannot change the value. Here savings is there. Here if I try to give something like current, okay, I am trying to reassign the different value to this particular variable. It's already assigned, this particular variable is already assigned with savings, but I'm trying to assign another value, say current, to this variable. If I try to do so, I'm getting a compile final field cannot be assigned. That means only one time you can initialize in the interface itself. There itself, while creating the variable, you have to initialize. Otherwise, Java will not allow. Once initialized, you cannot reassign the value. Okay, because this particular variable is of internally of final type. Okay, so its final also is proved. Okay, you cannot do such kind of operations here. Okay, it's a final. It's a constant. It's not a variable, guys. It's a constant, because this particular variable is specified with final. It becomes a constant. It cannot be changed. Constant means it will be constant, it cannot be changed. Variable value can be changed, but constant value which is specified with final internally cannot be changed. That's why you can call that as constant. Generally we specify the constants with full capital letters. If you have multiple words, you have to, the naming convention for the constants is account capital underscore type completely capital underscore 1. Okay, you can divide the words with underscore. Fine, other thing is public. Okay, so by default they are public, guys. Okay, if you try to specify private here, you will get a compiler error. Okay, it says that illegal modifier for the interface field. Okay, it can be only public. You can explicitly specify public. There is no need of explicitly specifying it as public, guys, but internally all the variables inside the interface are public by default. Okay, you can access them anywhere inside the project. So that's the intention. Okay, interface variables can be accessed anywhere inside the project because they are by default public. Even though no access modifier has been specified here, okay, by default internally this particular variable is of by default public type. Okay, if you try to provide any other type of access modifiers here like protected or private, you are immediately going to get the compiler error. Okay, hence this is internally or by default public case. So guys, the variables inside the interfaces can be created and they are by default public, static, and final type. You don't have to explicitly specify this public, static, finally, but internally Java will create these variables inside the interfaces as public, static, and final type as explained in this video. So that's it, guys. That's it about the interfaces and the variables. How they are how these variables inside the interfaces are public, static, and final type. Okay. So that's it. In the next video session, I'll explain about the interfaces and methods. Okay, the interfaces and methods. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 205 of Java for Tester series, that is interfaces and methods. Interfaces and methods. So guys, can we create methods inside an interface? Can we create methods inside interfaces? The answer is yes. Yes, we can create methods inside an interface. Okay, but guys, but without method body. If we have to create some methods inside the interface, we can create the methods, but without method body, we have to create. For example, let's say we have an interface like public interface, some bank. Inside this interface, we can create the methods. Let's say public void deposit amount. Okay, deposit money or deposit amount. If you try to create, if you try to create the method body like this, if you try to create the method body like this, you are going to get a compiler error. Okay, because interfaces doesn't allow you to create the method bodies. Only the method definition you can create. Okay, only you can define the methods, but you cannot create the body for the methods, guys. So can we create methods inside interfaces? Yes, we can create, but without method bodies. You see, this particular method doesn't have any body. Okay, it is just defined, but it's not, it doesn't have any body. Such kind of methods we can create inside the interfaces, guys. That's fine. Okay, that's fine. So next thing we need to know about the interfaces and methods is in interfaces we can create methods without method body. Okay, and also these methods that you are creating are by default public and abstract type. Okay, the methods inside interface are by default public and abstract, guys. If you don't specify, even though you don't provide this public access modifier before this method inside the interface, still it is a public access specifier method only, and also it's of abstract. That's the reason, guys, you are not able to create. That's the reason you are not able to create method body here, because by default the methods inside the interfaces are public and abstract type. Okay, they are internally specified with public and abstract. Even though you don't specify explicitly public and abstract before these methods inside the interface, these particular methods inside the interface are by default public and abstract. Okay, let me practically show you. Let's create an interface. Select right click new and select interface. Give some name like bank. Okay, this is an interface, guys. So public interface name, that is bank. Inside this interface, we can create methods, but without method body. Okay, so let's try to create method with some method body and see what will happen. Okay, let's say public void deposit amount. Okay, if I create a method like this with a method body, okay, if I provide this method body for this particular method, immediately I am getting a compiler error saying that abstract methods do not specify a body. Have I specified anywhere abstract like this? No, right? I can specify explicitly also, but when I created this method, did I specify abstract? No, right? That means these methods are by default abstract. You don't have to explicitly mention, okay, that these methods are by default. The methods that you create inside the interface are by default abstract. Okay, they are implicitly provided with the abstract. Okay, abstract non-access modifier internally. Though you don't specify explicitly, they are there internally. At same time, you don't have to specify this public, guys. Okay, these methods you can simply say void deposit amount. That will be fine. Okay, you don't have to explicitly provide public. Okay, because by default the methods inside the interface are public, okay, or public type, that is public access modifier type. For example, if I try to specify something like private, I am going to get a compiler error. There is no way, guys. Okay, illegal modifier, only public and abstract. Okay, public abstract are possible. So if I provide something like protected, okay, if I provide something like, even still I am getting the same compiler error saying the illegal modifier. Explicitly you can specify public case, but there is no need, because by default internally this particular method, even though you don't specify public here, all the methods inside the interface are by default public and abstract type. Okay, since they are public, you don't have to specify, and since they are abstract, you don't have since they are abstract, if you try to create a body for these methods, you are going to get a compiler error, because by default these methods are public and abstract type. Okay, next. So so we cannot provide private or protected kind of access modifiers here, and we cannot create body for these methods. Okay, because by default these methods are public and abstract type. Fine. So guys, you don't have to specify any access modifier here. You don't have to explicitly provide public here. So basically in interfaces, when you create methods, basically when you create methods inside the interfaces, it's a general rule that we don't have to provide any access modifier, because we already know that by default these methods are public and abstract type. Okay, you don't have to explicitly provide again. Fine. So guys, that's it about the interfaces and methods. Okay, but one more thing, guys. What about abstract classes and methods? Will abstract classes allow you to create private and protected kind of methods? Yes, guys, it's possible with abstract classes, but with interfaces, the methods inside the interfaces are by default public and abstract type. Okay, only the methods can be public type. You cannot provide private or protected with the methods which are there inside the interfaces. But coming to the abstract classes, you can create methods having private, protected, public, and all type of access modifiers there. But coming to interfaces, only public is allowed. Either you have to public explicitly provide public here, or you can ignore it. Okay, by default it will be public anyhow. Okay, by default the methods inside the interfaces are public anyhow, so you don't have to specify again. Fine. So that's it, guys. That's it about the interfaces and methods. In the next video session, I'll explain how to implement the interfaces. Okay, how to implement the interfaces. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 206 of Java for Tester series, that is implementing the interfaces. Implementing interfaces. Okay. So how to implement the interfaces? How to implement the interfaces is a question. So who will actually implement the interfaces, guys? So classes in Java can implement interfaces using a keyword known as, what is that keyword, guys? Implements keyword. Okay, so classes created in Java can implement an interface by using a keyword known as implements keyword. Let me practically demonstrate how the classes in Java can use this implements keyword for implementing a interface. For that, guys, let's create an interface first. Right click new interface. Name this interface as some bank. Okay. Click on finish. Public interface name. Interface name bank got created. Inside this interface, let's create some variables and methods. Say string account type 1 is equal to savings. Okay, savings account. Then string account type 2 is equal to some current account. Okay, then we'll create some methods like you don't have to specify the access modifier for the methods in Java because by default the methods you create are of public access modifier type. Okay, so void deposit amount. Okay, you don't have to explicitly provide public here. Okay, by default these methods are public. There is no need of providing. That's the reason I'm not providing, guys. Okay, you can provide if you want, but it's not required. Void withdraw amount, then void open fixed deposit. Like this, I've created some variables and methods. By default, the methods inside the interface are of public and abstract type. That's the reason, guys, this methods doesn't have any method body. Okay, only definition is there without any body. So now we have two variables and three methods inside this bank interface. Now let's create a new class. I'll name this class as Axis Bank. Okay, I'll move this to this side. As you can see that left side we are able to see the interface known as bank, and on the right side we are able to see the class known as Axis Bank. So I want this particular class to implement this bank interface. How to do that, guys? So we have to use a keyword known as implements. Okay. So when you create this class, public class name, beside the class name, you have to use this keyword known as implements. And whatever the interface that you want to implement inside this Axis Bank, that you need to provide here. Here we have an interface known as bank. I want to implement that. Okay. Here Axis Bank class is implementing the bank interface. So when you try to implement an interface, immediately you are getting a compiler error here. The reason here is this particular interface has some abstract methods which need to be implemented inside this class which is implementing this interface. So you can actually manually write down all these methods. Okay, public void deposit amount, you can create the body and all. So but Eclipse IDE will make your job easier, guys. You don't have to type each and every method inside this Axis Bank for implementation purpose. Rather, you can simply hover the mouse on this compiler error. It will give you some options like add unimplemented methods. Okay, add unimplemented methods. When you select that, all these three methods, deposit amount, withdraw amount, open fixed deposit, okay, are auto created inside this class along with the body. Okay, along with the method body. If you have the method body, that means you are implementing it, right? You are implementing the deposit amount abstract method of this interface bank. Okay, so instead of writing the original logic here, I will simply specify a print statement. Okay, so I will write down here depositing amount into Axis Bank account. Okay, depositing amount into Axis Bank account. Similarly, I will write another print statement inside this withdraw amount method also by typing withdrawing amount from Axis Bank account. Similarly, here also I'll create a statement, print statement, a sample print statement, opening fixed deposit in Axis Bank account. Okay, like this I can implement all the abstract methods of this interface. Whenever a particular class implements an interface, all its abstract methods need to be implemented inside that particular class. Okay, otherwise you will get a even if one method is missing, you are going to get a compiler error like this. Okay, the type access bank must implement the inherited abstract methods from bank interface. The pending method is open fixed deposit method. Okay, if you don't implement this open fixed, two out of these three methods are already implemented here. Here you can see deposit amount and withdraw amount are implemented. Only open fixed deposit is left. When you hover the mouse, it says the same thing. You have to implement this open fixed deposit abstract method of this interface inside this class, because this particular class is implementing this interface. So when you implement that, the compiler error will be resolved. So guys, the first thing about this implementing of the interfaces is that we have to use a keyword known as implements keyword inside the classes for implementing the interfaces, right? The second thing we need to know is it's not only about implementing this abstract methods of this interface. Apart from this methods, okay, apart from this methods of this apart from this methods of this interface, we can also have this particular access bank can have its own methods also. Okay, only it's not only about this. It's not only about inheriting the methods and implementing them from the interface. Rather, inside this access bank class, this access bank, apart from having the interface methods implemented, it can have its own methods. Let's say you can create something like public void, okay, open flexible fixed deposit, okay, open flexible fixed deposit. Let's say this access bank is providing a new option where you can convert your savings account into flexible fixed deposits. Okay, you don't have to manually open a fixed deposit. Rather, when you have some good amount in your savings account, automatically those savings will be converted into the fixed deposits. That plan in Axis Bank is known as flexible fixed deposit, let's say. Okay, so this kind of feature is only specific to this Axis Bank. Okay, not for the entire banks in the country. Rather, only Axis Bank has this option. Such kind of specific methods can be created. Okay, so opening flexible fixed deposit in Axis Bank account. Okay, so here, as you can see, these three are inherited methods from the interface. Okay, inherited and implemented methods in the interface of the interface. But this particular method is specific to the Axis Bank. So when a particular class implements an interface, it has its own specific methods also, along with the methods inherited and implemented from the interface. Along with the methods inherited from the interface, this class will also have its own methods. Okay, that's possible. Fine. So guys, that's good. Now, one more thing we have to understand here is, what if I don't want to implement one of the abstract method of the interface inside this class which is implementing the interface? Let's say I don't want to implement this deposit amount. I will remove from here. Immediately, I'll get a compiler error saying one of the method, that is deposit amount method of the interface, is not implemented inside this Axis Bank class. Okay, despite of this Axis Bank class implementing this interface, one of the method of this bank interface, that is deposit amount, is not implemented inside this class. That is a compiler error. So as I already shown you, you can either implement that method inside this same Axis Bank class, or there is another way, guys. Okay, what is the other way? You have to make this Axis Bank class as an abstract. Okay, you have to make this Axis Bank class an abstract. Then only this compiler error will be resolved. When you make this Axis Bank class abstract, okay, you don't have to implement all the abstract methods of this bank interface. Rather, only few you can implement. But guys, who will implement this particular abstract method of this interface then? Okay, only two methods out of these three methods are implemented inside this Axis Bank. Who will implement the other third method, that is the deposit amount method, okay, of the bank interface? For that, guys, what we can do is we can create another class, new class. Okay, this is not correct, but I will write something like this: Axis sub bank. Okay, Axis sub bank. Click on finish. I'll make this Axis sub bank as a child class. How can I make this Axis subbank as a child class of this Axis Bank class? Which keyword we have to use, guys? If you want a particular class to be a child class of this Axis Bank class, which has to become the parent class, in that case, okay, which keyword we have to use for inheriting? Which keyword we have to use? We have to use a keyword known as extends keyword, right? A class extending another class. Here, this class will become the child of this class. Okay, extends Axis Bank. Okay, so when if this particular Axis Bank class, which is of abstract type here, has a child class, then the child class need to implement this unimplemented method of this bank interface. Okay, if the Axis Bank class here, if a class implementing the interface is not implementing all the methods of the interface, then its child class has to implement it. Okay, just understand this point, guys. If a class implementing the interface is not implementing all the methods of that particular interface, in that case, the child class of this particular class has to implement that particular method. So here, since this Axis Bank has only implemented 2 out of these 3 abstract methods of this interface, the child class of this Axis Bank has to implement the remaining method. Okay. Over the mouse, you see the type Axis subbank must implement the inherited abstract method bank dot deposit amount. Okay, like this, simply like this, guys. Okay, so you can implement the unimplemented method of this interface in the child class of the abstract class if it is not implemented here. Okay, hope you understood what should be done. Okay, these are the different ways, guys, of implementing the interfaces in Java. Okay, so that's it, guys. This is all about implementing the interfaces in Java. In the next video session, I'll explain the next topic of interfaces, that is interfaces and the object creation. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 207 of Java for Tester series, that is interfaces and object creation. Interfaces and object creation. So guys, to get started, can we create objects for the interfaces? Can we create objects for the interfaces? The answer for this question is no, guys. No, we cannot create objects for the interfaces. If we try to do so, we are going to get a compiler error in Java. Okay, we cannot create objects for the interfaces in Java, guys. If we try to do so, we are going to get the compiler error. So let me compare two things here. On the left side, let me compare abstract classes. On the right side, we have interfaces. Can we create objects for the abstract classes? Can we create objects for the abstract classes? The answer is no here also. We cannot even create objects for the abstract classes, and also we cannot create objects for the interfaces. So let me practically demonstrate that we cannot create objects for the interfaces, and if we try to do so, we'll get the compiler error. Let me demonstrate creating the objects for the interfaces and getting the compiler error, as creating the objects for the interfaces is not possible in Java. So guys, let me create an interface. Right click new interface and give an interface name, say bank. Click on finish. We have created an interface known as bank, and I will create some variables and methods inside this interface. That is string account type 1 is equal to savings account. String account type 2 is equal to current account. Okay, current account, savings account and current account. Now I'll create some methods. You don't have to specifically mention the access modifiers here, because the methods inside the interface are by default public and abstract type. Okay, void deposit amount is one method I will create. It will not have any body because by default this particular method inside the interface is of abstract. You cannot create body for the abstract methods in Java. And also you don't have to specify it as public because by default this method is of public. You don't have to specify any access modifier because only public is allowed. And by default this method is of public. As explained in one of the previous videos, the methods inside the interfaces are of public and abstract type by default. Void withdraw amount is another method. Then void open fixed deposit, okay, is another method. Like this, in this particular interface known as bank, we have two variables and three methods. Fine. Now guys, let's create a class known as demo class, which has this main method inside it. So I'm going to drag this to the right side so that you can see both interfaces and this demo class together. So inside this main method, I would like to create an object for this interface known as bank. So can I create an object for this interface, guys? No, guys, the answer is no. You're going to get a compiler error. Let me show you practically. So bank is equal to new bank. I create an object for the bank interface and I got this compiler error saying that cannot instantiate the type bank. That means you cannot create an object for the bank interface. So objects cannot be created for the interfaces in Java, and if you do so, you'll get the compiler error. Okay, as mentioned here. Fine. So guys, then how? Okay, then how? If you are not able to create, if you are not able to create objects for the interfaces, then how can you access this methods of this bank interface? Okay, how can you access this methods of this bank interface? The answer is you can create some classes which can implement this interface and you can create the objects for those classes. Okay. So let me drag it here so that it will not be a problem. Okay. Now what I will do is I will create a new class which can implement this interface. I'll name this class as Axis Bank. Okay. Click on finish. Drag it to the right side so that you can see both this bank interface and Axis Bank class together. I would like to make this Axis Bank class to implement this bank interface. Implements bank interface. So when this particular class implements the bank interface, all these abstract methods of this interface has to be implemented inside this implementing class. Okay. So hover the mouse on this and say add unimplemented methods. So all the unimplemented methods of the interface will be displayed here. Okay. So I will try to implement them. So this is the body of this method. So inside this method, I will write a print statement saying system.out.println depositing amount in Axis Bank, okay, account. Similarly, I'll implement another method that is withdraw amount of this interface inside this Axis Bank class by saying system.out.println withdrawing amount from Axis Bank account. Third method, I'll write a sample statement for as part of implementation by writing opening fixed deposit in Axis Bank account. Like this, I implemented all the abstract methods of this bank interface inside this Axis Bank. Fine. Along with this inherited and implemented abstract methods of this bank interface, okay, this particular Axis Bank can also has its own or specific methods of this Axis Bank. Okay, this Axis Bank can also have its own methods apart from the inherited methods. This Axis Bank can have its own methods. Okay, let's say there is a method like public void open flexible fixed deposit. This feature is only there in the Axis Bank. Let's say, okay. So in Axis Bank, if you are holding an account in Axis Bank, you can open a flexible fixed deposit account. Okay, so I'll write here system.out.println. This particular method is not inherited from the interface, guys. Rather, this particular method specifically belongs to this Axis Bank itself. Okay. All the other three methods are implemented by inheriting from the interface, whereas this method is specific to the Axis Bank account. So I'll write a statement saying opening flexible fixed deposit in Axis Bank account. Fine, like this. Now guys, this Axis Bank class is implementing this bank interface and has implemented all the inherited abstract methods of the interface. Along with that, it has its own specific method. Now, I cannot create an object for the bank interface directly, right? If I try to do so, I'll get a compiler error. If I say bank is equal to new bank, I'm going to get a compiler error saying that you cannot create an object for the bank interface. But I can create object for the classes which are implementing the interface. That means I can create an object for this Axis Bank here. So Axis Bank Axis is equal to new Axis Bank like this. Okay. I can create an object for the Axis Bank, which is implementing the Axis Bank class, which is implementing the bank interface. Now, with this object reference of this Axis Bank, I can access all the inherited methods of the bank interface along with the specific method of this Axis Bank. Okay. Axis dot, I can say deposit amount. Axis dot withdraw amount. I can say Axis dot open fixed deposit. I can also say Axis dot open flexible fixed deposit. So these three are the interface methods, whereas this one is the method which is specific to this Axis Bank. Using the object of this Axis Bank class, which is implementing the bank interface, I can access all the methods of this bank interface. Along with that, I can access the method which is specific to the Axis Bank. Okay, like this, we can create the object for the Axis Bank class, which is implementing the bank interface, and then access all the methods. Fine. So next thing is assigning the object of implementing class to the variable of the interface. What does it mean? So I'll clear this out. What I mean to say here is I cannot create an object for the bank interface. If I try to do so, I'll get a compiler error. Bank is equal to, if I say new bank, okay, I'll get a compiler error saying that you cannot create this new keyword is creating an object for the bank interface. This new keyword in Java is trying to create an object for the bank interface, which is giving you the compiler error. Okay, cannot instantiate the type bank. So guys, if you're not able to create an object for an interface, can you create a variable for the interface? Can you create a variable and define that variable with bank interface type? Yes, you can do so. Okay. Only thing is that you cannot create an object for this bank interface. Okay. You cannot create an object for this bank interface, but you can create a variable and define that variable with bank interface type. Only this part is possible. But if you say is equal to new bank, this is not possible. Okay. You cannot create an object for the bank and assign to the variable of the bank interface. You can only create a variable and define that with bank interface type. Up to this is possible. So for this particular variable of bank interface type, if you try to assign, okay, can you assign an object of this Axis Bank class which is implementing this interface? Yes, guys. Okay. So what I mean to say here is I'm creating here on the right side, I'm not creating an object for the bank interface. On the right side, I'm not creating an object for the bank interface. Rather, I'm creating an object for the Axis Bank class which is implementing the bank interface. Okay. This will create an object for the Axis Bank class which is implementing the interface. And this object is getting assigned to the variable of the bank interface. This statement is possible, guys. Okay. This statement is possible. You can create an object for this class which is implementing the interface and assign that object to the variable of the bank interface. So using such object reference, okay, which is defined with using such object reference which is defined with bank interface type, what are the different methods I can access? Can I access all the methods of this Axis Bank? The answer is no, guys. Okay, I cannot access all the methods inside this Axis Bank. Rather, using this reference, using such kind of reference in the statement, you can only access the methods which are implemented. The methods which are inherited and implemented from the bank interface can only be accessed, guys. The method which is specific to the Axis Bank cannot be accessed using this object reference. Okay. If this particular variable is defined with this bank interface and then assigned with the object of this Axis Bank, using this object reference, you can only access the methods which are inherited and implemented from the interface. Okay, this method cannot be accessed. Let me show you. So I can say bank dot deposit amount. Okay, I can say bank dot. I'm able to access, guys. Okay, bank dot withdraw amount. I can say bank dot open fixed deposit. I can say all these things. Okay, because all these methods are belong to the bank interface and they are inherited inside this Axis Bank class, right? Now, if I say bank dot open flexible, I'm not able to do access, guys. Okay, I'm not able to access bank dot open flexible flexible fixed deposit is not possible because this method belongs to the Axis Bank. Here we are creating an object for the Axis Bank and assign to the variable of the interface. In such kind of cases, using this object reference, you can only access the methods which are inherited from the interface only. Okay, the bank interface methods only can be accessed. Okay, the bank interface methods which are implemented in the Axis Bank can only be accessed using this object reference. But the method which is specific to this Axis Bank cannot be accessed with such kind of object reference or variable. Okay, fine. Now, guys, but still I want to access this method using this bank. So what I have to do? So let's say what I will do here is bank. I'll typecast this bank, guys. Okay, so I'll put this bank inside this circular brackets and I will typecast it to Axis Bank class. Okay, I am typecasting this bank object reference with this Axis Bank class. Okay, dot open. Now you are able to access, guys. Okay, so directly if you say bank dot open flexible fixed deposit, it cannot be accessed, guys. In order to access, we have to typecast this particular bank type of from bank to the Axis Bank type. Then only you can access. Okay. So guys, these are all the things. Okay, so if you directly create an object for this Axis Bank access is called new access, then all these methods, including the inherited methods and the specific methods of this Axis Bank, can be accessed using that object reference. But if you create an object for the Axis Bank and then assign to the variable of the bank interface, then only the methods which are inherited and implemented in the Axis Bank can be accessed. But the method which is specific to the Axis Bank cannot be accessed such kind of variable. If you still want to access such kind of method, okay, which specifically belongs to the Axis Bank here, then you have to typecast it to the Axis Bank, then you only you can access. Okay, fine. So casting is done. The last thing is that why we have to assign an object of the Axis Bank class which is implementing the interface. Okay, why we have to create an object of a class which is implementing an interface and assign it to the variable of the interface. What is the purpose? Let me explain the purpose. Okay, let me explain the purpose. Why we have to create an object for this class implementing the interface and assign to the variable of the interface. We can directly say Axis Bank Axis is equal to new Axis. Like this I can say, right? I can directly create an object for the Axis Bank. But why I'm creating an object for the Axis Bank and then assigning to the variable of the bank interface? Why this kind of statement is really required in Java? Okay, let me explain. So guys, what I will do here is I already created an Axis Bank class here. Let me create other classes also. Let's say I'll say HDFC Bank. Okay, I'll create multiple classes. So here I'll drag it here. I'll implement this HDFC Bank. HDFC Bank, I'll say implements the bank interface. Here, Axis Bank is implementing this bank interface. At same time, HDFC Bank is also implementing the same bank interface. Okay. So here you have to say over the mouse on HDFC Bank and say add unimplemented methods. So I'll implement the methods inside this HDFC Bank also in the similar manner I did for the Axis Bank. So I will say depositing amount in the HDFC Bank account. Okay. Similarly, for the withdrawing the amount also, I will implement something like this. Withdraw the amount. Paste it here. Withdrawing the amount from the HDFC bank. Since I am implementing this HDFC bank, since I am implementing this methods inside the HDFC bank, I have to write the statements according to the HDFC bank account. Okay, fine. The other thing is like opening fixed deposit. Okay, I'll write it here inside HDFC bank account in HDFC bank account. So apart from this HDFC bank, I will create another class also. Okay, another bank class which can implement the same bank interface. That is ICICI Bank. Click on finish and I will drag it here. I'll say implements bank interface. This particular ICICI bank also implements the same bank interface. And hover the mouse on this compiler error and say add in unimplemented methods. Now let's implement that methods, the same methods in different class. So withdrawing the amount from the which bank? ICICI bank. Then sorry, this one is depositing, right? This is withdrawing, which should be there inside this withdraw amount method. And depositing should be there here. This is ICICI bank account, and last one is opening fixed deposit inside the ICICI bank. Okay, here instead of Axis I will write ICICI. Now guys, how many classes we have? We have three classes: Axis Bank class, HDFC Bank class, and ICICI Bank class. Like three classes are there, and all these three classes are implementing the bank interface. Axis Bank is implementing the bank interface. HDFC Bank is implementing the bank interface. ICICI Bank is also implementing the bank interface. And as these classes are implementing the interface, they have implemented the methods in their own way. Okay, they have implemented the abstract methods of the bank interface in their own way. If you come to the Axis Bank, it has implemented by saying deposited into Axis, withdrawn in from Axis, opening in Axis. Coming to HDFC, it has implemented, this particular class has implemented this methods of the bank interface in its own way, saying depositing in HDFC, withdrawing from HDFC, opening in HDFC. Okay, like that. ICICI also, it's in own way, saying depositing in ICICI, withdrawing from ICICI, opening fixed deposit in ICICI. Like that, if you have multiple classes implementing the same interface, now you will get the answer, guys. Okay, in this kind of situations you are going to get the answer why we have to create an object for the classes implementing the interface and assign to the variable of that particular interface. Okay, if I say string, I can write such kind of logic, guys. Okay, so here I'm explaining the purpose, guys. You have to come to this point, like the purpose of assigning the object of the implementing classes to the variable of the interface. Okay, so why we have to do so, I'm just explaining. So with this logic that I'm writing here, you will able to understand why we are assigning the object of the implementing classes to the variable of the interfaces. Okay, string, I'll say bank name is equal to, I can give any bank name here. Let's say if I give access here, then here I will write the logic like this. If so, before writing if here, I will say I'll write something like bank. I can create a variable for the interface, right? I cannot create an object for the interface. Bank is an interface. I cannot create an object for the interface, but I can create a variable for the interface like this. Bank. I can say I can create a variable for this interface. I can define a variable as bank interface type. That's possible. But I cannot create an object for the interface. I can create a logic like this. If this bank name, the given bank name dot equals, okay, if the given bank name equals axis, I will write a statement like this. Okay, and before doing so, I'll assign some null here. Okay, I'll assign null to this bank variable of the bank interface. So before assigning anything, I'll assign a null here. Now if this bank name, if the bank name of this particular variable is provided as axis, in that case what I will do is I will say bank is equal to, bank is a variable of the which interface type, bank interface type. Bank is equal to, I'll create an object for axis bank like this. Okay, so what if else if I say bank name dot equals, if it is HDFC, okay, in case if it is HDFC, then to the same variable of the bank interface, in this case, I will assign the object of which class? HDFC bank class, okay. So guys, I'm generalizing. As you can see, the variable is same, right? Bank is there, but the object is differing here. I can assign the object of the Axis Bank, the variable of the bank interface. Same time, I can assign the object of the HDFC Bank to the variable of the bank interface, because this Axis Bank, this HDFC Bank are implementing the bank interface only. That's the reason I can create an object for the Axis Bank or HDFC which are implementing the bank interface and assign it to the variable of the bank interface like this. Okay. I'm generalizing the things. Bank name, if bank name dot equals ICICI, okay, if it equals to ICICI, in that case, the object of the ICICI bank need to be assigned to the variable of the bank interface. So here the variable is same, but the objects are differing. Like this, multiple objects of different classes implementing the interface can be assigned to the variable of the bank interface. Okay, that's the reason, guys. We can create an object for the classes implementing the interface and assign to the variable of the interface. So such kind of programs are possible only when you create an object, only when you create object for the classes implementing classes of the interface and assign to the variable of the interface. Okay. Now simply I can say bank dot deposit amount, bank dot withdraw amount, bank dot open fixed deposit. Okay, like this I can write the code. Fine. So what will happen when I run this code now? When I run this demo.java, what will be the result, guys? Here the bank name is Axis. So here the logic will go here, guys. Okay, bank name dot equals Axis. Okay, this bank name is Axis. Axis dot equals Axis is true. So it will go inside this first if block. Then bank is equal to new Axis Bank. So object of the Axis Bank will be assigned to the variable of the bank interface in this case. And all this remaining else if will be skipped. And here bank dot deposit amount. Which method will be called? The method deposit amount implemented inside the Axis Bank will be called this, because currently the object of the Axis Bank is assigned to the variable of the bank interface. So bank dot deposit amount means this method inside the Axis Bank. So that is nothing but depositing amount in the Axis Bank will be printed. Okay. Similarly, withdrawing amount from the Axis Bank, opening fixed deposit in Axis Bank will be printed. Let's run this and see whether we are getting the correct results. You see, depositing amount in Axis Bank, withdrawing amount from Axis Bank, opening fixed deposit in Axis Bank. What if I change this text to HDFC? What will happen, guys? So here, when I run this main program, so the bank name is HDFC. So the logic will be checked here. HDFC dot equals Axis. True or false? False. So this block will be skipped. It will go to the next if condition, that is HDFC dot equals HDFC. It's true, guys. So the object of which class will be assigned to the variable of the interface? The object of the HDFC class, HDFC bank class is getting assigned to the variable of the bank interface. So here when I say bank dot deposit amount, which methods, which deposit amount will be called? The deposit amount method which is there inside this HDFC bank will be called, guys. Okay. Withdraw amount method which is there in the HDFC will be called, because we are assigning the object of the HDFC bank to the variable of the bank interface in this case. Like this, such kind of programs you can create, guys, if you create objects for the classes implementing the interface to the variable of the interface type. Okay. So run this, right click run as Java application. We should get the result as HDFC, depositing, withdrawing, opening. What if I change it to ICICI? It's very easy now, right? ICICI. So ICICI equals Axis, false. So this will be skipped. ICICI dot equals HDFC is also false. This will also be skipped. Last if condition, that is ICICI equals ICICI, true. So object of the ICICI bank is getting assigned to the variable of the bank interface, and all the methods inside the ICICI bank will be called using this variable of the bank interface. Okay. So if I run this, right click run as Java application. You see, depositing amount in ICICI bank, withdrawing amount from ICICI bank, opening fixed deposit in ICICI bank. So this is the purpose, guys. This is the purpose of assigning the objects of the implementing classes of the interfaces to the variable of the interface. Using such kind of feature available, we can create or implement such kind of logic like this. Okay, based on the logic, we can assign any object of this any class implementing the interface to the variable of the interface and get such kind of programming results. So this is all about the interfaces and object creation in Java, guys. In the next video session, I'll explain the next topic on the interfaces, that is implementing multiple interfaces. Okay, so that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 208 of Java for Tester series, that is implementing multiple interfaces. So a class can implement multiple interfaces at the same time. Okay, let me explain. Implementing multiple interfaces. Let's say there are multiple interfaces, and these multiple interfaces can be implemented by a single class. Let's say this is interface 1. We have created multiple interfaces, let's say interface 1 and interface 2. And there is a class here which actually implements both these interfaces at the same time. This class implements this interface 1, and also this class can implement the interface 2. So not only two interfaces, guys, as many number of interfaces as possible this particular class can implement. Okay, there is no restriction. A single class can implement multiple interfaces. Fine. So if you remember, in one of the previous videos, I explained about multiple inheritance, right? So multiple inheritance is not possible in case of classes when extending. Okay, in case of inheriting multiple classes, it's not possible. For example, what I mean to say is, let's say there is class 1 and class 2, and here let's say there is some class A. So this class A cannot extend multiple classes at the same time. Okay, as I already explained in one of the previous videos, a single class cannot extend multiple classes. This is not possible. What I mean to say is, public class A extends class 1 comma class 2 is not possible in Java. Okay, this particular thing is not possible in Java. A single class cannot extend multiple classes like this. You are going to get a compiler error if you do so. So that's why we can say that classes cannot extend multiple classes, and hence multiple inheritance is not possible in this case. In this case, the multiple inheritance is not possible. Let me show you practically. Let's create some 3 classes. Class 1. So inside this class, I will create a method like public void some method 1 system.out.println inside method 1. I'll create another class. I'll name this as class 2. You can name anything, guys. I'm just taking few examples like that. Class 2. And this class 2, let's say it has some method 2. Inside this, I'll write a print statement saying inside method 2, like this. Now I'll create another class known as class A. You can give any name, click on finish, put it here somewhere, and I want to make this class A extend this class 1 and class 2 as part of inheritance. Extends class 1. This is possible. A class can extend a single class is possible. Can I extend multiple classes, comma, if I say class 2, I am going to get a compiler error. Okay, it doesn't allow you guys. Only a single class can extend only single class. A single class cannot extend multiple classes. That's the reason multiple inheritance is not possible in this case. But coming to the interfaces, okay, inheriting the as part of inheriting the classes, multiple inheritance is not possible. But as part of inheriting the interfaces, a class can inherit multiple interfaces. So multiple inheritance is possible in case of interfaces, guys. Okay, what I mean to say here is, let's clear out all this stuff. Let me create multiple interfaces first. Okay, let me first create multiple interfaces. So let's start by creating one. That is, I will say the interface name is like walk. Okay, finish. It's an interface, guys, not a class. It's an interface. So I'll create some method inside this. Void walking is a method which doesn't have any body because all the methods inside the interface are by default abstract and cannot have body. Fine. I'll create another interface. I'll name this interface as fly. Click on finish. This is another interface. Fly is another interface, and I'll create one method inside this interface like flying. Fine. These are two interfaces now. I'll create a new class. I'll name this class as some bird. Finish. It's a class, guys. Okay, I'll drag it here so that you can see all the things at the same time. So I want this bird class to implement both this walk and fly at the same time. Like I want to make this bird class implement multiple interfaces, that is walk and fly. So how to implement the interfaces, guys? How to inherit the interfaces? We have to use implements keyword. Implements walk. Okay, bird implements walk, comma fly. This is allowed, guys. This is allowed. Okay, in Java this is allowed. So when you hover the mouse on this bird, it says that you have to implement the unimplemented methods of these both interfaces, that is walk and fly. First, it is asking you to implement the inherited abstract method fly. Okay, let's implement public void flying. I'll write down here saying system.out.println bird is flying. Bird is flying. Still the error is there because this flying is there in the fly interface, which I have implemented in the bird class, which is implementing the fly interface. But we have not implemented the abstract method of the walk interface. That is the reason the compiler error is still there. It says that the type board must implement the inherited abstract method walking also. Okay, not only flying, we also have to implement the walking. So let's implement the walking. Public void walking, abstract method of the walk interface I'm implementing in the bird class, because bird class is implementing the walk and fly interfaces. So bird is walking. Like this, I have to implement. You see the compiler error has been gone. So that means that this means that a single class can implement multiple interfaces. A single class can implement multiple interfaces. That means multiple inheritance is possible in case of interfaces, but not in case of classes. Okay, you have to remember that. Fine. So let's complete this program by creating a demo class. Demo with main method. I'll drag it to the right side and here. So inside this, I'll create an object for the bird class. Bird is equal to new bird. Now using this object reference bird dot walking, bird dot flying. Okay, bird dot walking, bird dot flying. So when I run this, you'll get the output as bird is walking, bird is flying. So that means that multiple inheritance is possible in case of interfaces and not in case of classes in Java. Okay, so this is what about implementing multiple interfaces, guys. In Java, a single class can implement multiple interfaces. Okay, a single class in Java can inherit multiple interfaces using the implements keyword. So that's it, guys. In the next video session, I will explain about an interface implementing another interface. An interface can also implement another interface, which is possible in Java. So I will explain about this in detail in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 209 of Java for Tester series, that is interface extending another interface. Similar to classes, we can make an interface extend another interface in Java. That means an interface can inherit from another interface in Java. So let me practically demonstrate on how an interface can extend or inherit from another interface. Fine, let's create an interface, say sports. Click on finish. This is an interface, guys. Inside this, I'll create some sample method, say void create team. Similarly, I'll create another interface. I'll name this as basketball. Click on finish. Drag it here so that you can see both the interfaces at the same time. I want to make this basketball interface a child interface of the sports parent interface. Okay. So before I do so, I'll create some sample method inside this basketball saying void team score. Okay. Fine. Here I want to make this basketball interface a child interface of the sports interface. Which keyword I have to use, guys? I have to use extends keyword in Java. Okay. Basketball interface extends sports interface. Now the sports interface has become the parent of this basketball child interface. Fine. Now when the situation is like this, let's create a new class. I'll create a class known as Sunrisers. Okay. So what I will do here is, as part of the experimentation, I'll make this class implement this basketball and see what will happen. Okay. Implements the Sunrisers class implements an interface known as basketball, which is a child interface of the this basketball is a child interface of the sports interface. So when a particular class implements a child interface class, what will happen? Nothing, guys. This particular class not only has to implement the methods of the basketball interface, but also its parent interface also. That means both this create team and team score methods of this parent and child classes has to be implemented inside this Sunrisers, because the Sunrisers class is implementing the basketball child interface. That's the reason you have this particular class has not only have to implement the abstract method inside the basketball child class, but also basketball interface, but also its parent interface method, that is create team. So both the methods, the child and parent interface, has to be implemented inside this class if this class is implementing the child interface. Hold the mouse and say add unimplemented methods. You see, create team and team score, both the things have come up. So let me write down some sample code here saying system.out.println Sunrisers team creating Sunrisers team, let's say. Okay. And here also I'll write some print statement saying system.out.println calculating Sunrisers team score. Fine, like this. So to see that everything is working fine, I'll create a demo class with main method. And we'll try to create an object for this Sunrisers class and see whether I can get the things done. So I will say Sunrisers risers is equal to new Sunrisers, let's say, and I will say risers dot creating risers dot team score, like this. Okay, two methods I create. I'm calling. So let's run this and see whether things are working fine or not. You see the two implemented methods of the parent and child interfaces inside the Sunrisers class are being called and they got executed also. Creating Sunrisers team got printed and calculating Sunrisers team score also got printed. Like this, guys, an interface in Java can extend another interface. Okay, an interface in Java can inherit another interface. Here sports is the parent interface and basketball is the child interface. And in such kind of cases, a class is implementing the child interface. Okay, a class is implementing the child interface. Then that particular class has not only has to implement the method of the basketball or child interface, but also the method of the parent interface has also be as also has to be implemented inside this class. Okay, both the methods of the child interface and parent interface has to be implemented inside this implementing class. Okay, child interface implementing class. Fine. So guys, so that's it about the interface extending another interface. The next video session, I'll explain extending both the classes and interfaces at the same time. Okay, we can extend a class can extend another class and interface at the same time. That thing I'm going to explain in the next video session. So that's it guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 210 of Java for Tester series. That is extending classes and implementing interfaces together. So a class in Java can extend classes and implement interfaces together guys. Okay, this is possible in Java. A class can at the same time extend classes and implement interfaces. So let me practically show you how this is possible. Okay, how this is possible. For that, let me create a new class. I'll call this class as class X. Finish. Inside this class, I'll create a sample method saying public void the method X. I'll write a sample print statement saying system.out.println inside method X of class X like this. Okay, fine. Now I have created a class. I'll create some interfaces. Say interface Y. Finish. You can give any name guys. I'm just giving interface Y here. So here I will say interface Y. I will create some sample method inside the interface void method Y without any body. Now I'll create another interface. Say interface Z. Click on finish. Click on finish. I'll move this side so that I can. Okay. Inside this interface, I will create a method also. Some sample method say method Z. So now I have one class and two interfaces, right? Class X, interface Y, interface Z. Now I'll create another class. I'll name this class as some class A. Finish. I'll drag it down here. I want this particular class to extend this class and implement these interfaces. So the same class has to extend this class and implement these interfaces. So how to do that? How to extend a class, guys? How to make this class a child class of this class X? Using the extends keyword. I can say class A extends class X. This is possible, right? Class A is extending class X. Class A is inheriting class X. Class A is the child class of the class X parent class. At the same time, I want to implement this interfaces also by this class. I want this particular class A to implement this interfaces also. So how to do that? I have to use a keyword known as implements. Extends class X implements interface Y, comma, interface Z. Okay. A class can implement multiple interfaces. So that's possible. So when I do so, I'm getting a compiler error saying that I have to implement all these methods of these interfaces. So hover the mouse on this class A and select add unimplemented methods. So method Z, method Y of the interfaces have fall in place. Here method X is being inherited by class A. At same time, the unimplemented methods of this interface has to be implemented in this class A because class A is implementing these interfaces. So inside this method, I will write down some sample print statement saying inside method Z. Here also, I'll write down the same thing saying inside method Y. So to see everything is working or not, I'll create a demo class, some demo class with the main method inside that. So I will drag this demo class here. Okay, inside this demo class, I'll create an object for this class A and try to access this inherited method and this implemented methods of this abstract methods of the interfaces. Okay, so class A is equal to new class A, like this. If I say A dot method X, I can say A dot method X because class A is the child class of the class A. Class A is the child class of the class X. That means the method that is there in the class X is now part of the class A because class A is inheriting the properties of the class X. So if I say A dot, I can say A dot method X, right? Using the child class object, I can access the parent class method. So A dot method X, which is inherited by the child class, is being accessed using the object reference of the child class. Fine. In the same way, I can say A dot method Y because this method Y is the abstract method of the interface which is implemented in the class A. Okay, class A is implementing the interface Y. So its method has to be implemented in the class A. So using the object reference of the child class, I can access that method. And similarly, method Z, like this case. Okay. So when I run this demo.java, all the methods will be accessed and printed. Okay. All the methods will be accessed and executed and printed inside method X of class Y, inside method Y, inside method Z, like this, guys. So guys, this is how we can extend classes and implement interfaces at the same time. A class in Java can extend a class and at the same time implement another interfaces at the same time, guys. So that's it, guys. This is all about the interfaces. The next video session, I'll explain about the abstract classes in Java. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 211 of Java for Tester series, that is abstract classes. So what are abstract classes? So in order to understand the abstract classes, you need to understand this requirement, guys. Let's say you got a requirement in your project like this. That is, you got a requirement in your project. Say, what is that requirement? That the parent class, okay, this is the requirement, guys. The parent class has to provide the default implementation of few methods. Okay, the parent class has to provide the implementation. Okay, otherwise you can say the parent class has to provide the implementation of few methods and has to keep the other methods open for the implementation in the child classes. So what I mean to say here, is, let's say if you got a requirement like in a particular class, let's say this is a class, okay, a particular class, you don't have to implement all the methods, okay, only few methods you have to implement. Let's say these are the methods to be implemented, and other methods you don't want to implement, okay, you just want to define them without body, guys. Define means only the method definition will be there, but method body will not be there. Implemented means method definition and body both will be there. Suppose you got a requirement in your project where the parent class, this class A is going to be the parent class. Let's say this is the parent class, okay, of some child class. Okay, class A is the parent class. Some parent class, you got a requirement where you need to create a parent class which has to provide the implementation for few methods. Okay, that is method definition and body it has to provide. Along with that, few other methods, okay, has to be just defined. Okay, these methods need to be implemented by the child classes. Okay, some child class, say class B or something. Okay, let's say class B for example. Okay, so let's say the class B is the child class of this class A parent class. and you got a requirement where the parent class has to implement only few methods and remaining methods it has to only define. Okay, it has to only define, it should not implement. Only the method definition will be there, method body will not be there. Such methods need to be implemented by the child classes. Okay, the parent class has to keep this defined methods for the child classes to be implemented, child classes of this parent class to be implemented. Okay, so in such kind of cases we have to use what, guys? We have to use abstract classes in Java. Okay, so if you use abstract classes in Java, if we make this parent class as an abstract class, this parent class can implement few methods which has to be implemented, and remaining methods it can just define them, so that these methods are kept open for the child classes of this parent class to be implemented. Okay, child classes of this parent class will implement these methods which are just defined in this parent class. If any case you get such kind of requirements, you have to go with the abstract classes in Java, guys. Okay, so if you understand this requirement, you will understand the abstract classes better. So I will try my level best in explaining you what exactly these abstract classes are by comparing this abstract classes with the interfaces. Let's say this side we have the interfaces, and this side we have the abstract classes. Okay, abstract classes in Java. So guys, in the previous videos, okay, in the previous videos I explained about the interfaces. So if you compare these interfaces with the abstract classes, the interfaces are 100% abstract. Okay, they are fully abstract, whereas abstract classes are partially abstract. Partially abstract, not fully abstract. They are partially abstract. That's the reason, guys, here this parent class is implementing some methods and it's only defining some methods. This defining methods are nothing but abstract methods. Okay, few methods are like only definition will be there, body will not be there. So abstraction is there here, but implementation means abstraction is gone, completely implemented. Okay, so in interfaces all the methods are going to be abstract, fully abstract. Only definition of the methods will be there in the interfaces. But coming to abstract classes, you can have both type of methods. Okay, methods with implementation, methods without any implementation. Here only the methods without implementation should be there. All the methods in the interface should not have any method implementation. Only method definition will be there for all the methods in case of interface. But coming to the abstract classes, they are partially abstract. That means few methods can be implemented, few methods cannot be implemented. Fine. So guys, let me explain more, okay, about these abstract classes in a practical way. Let's create some abstract classes now. Okay, let's create some abstract classes now. So how to create an abstract class? First, let's create a class, and later let's make that class as an abstract class. First, let's create a normal class. I'm creating this right-click new class, and I'm giving the name of the class as some class A. You can give any name here and click on finish. So this is a normal class, guys. Okay. If I put some abstract non-access modifier before this class, then this particular class will become an abstract class. So here now the class A is nothing but an abstract class. As explained, the abstract classes can have both abstract and non-abstract methods. Okay. Here partial abstraction is there. That means normal methods and abstract methods can be there. Abstract methods are the methods which are just defined. Okay, they are not implemented. Non-abstract methods means they are implemented. They have some code. Let's write down such kind of things. Okay, so public void some method x. Okay, I'm just providing this is a method definition and this is a method body, guys. Okay, I'm just implementing this method x. System.out.println. Okay, inside method x. And other method I will write something like this: public void method y, and I'm only just defining it, and I'm trying to make, I have to keep this method as abstract. Okay, I have to keep the abstract keyword before this method, because this method I want to only define. I don't want to implement this method. Instead I want to only define this method. Okay, I want to only define this method but not to implement. So such methods I have to specifically mention as abstract here. Okay, if I put abstract keyword here before this method, method will become abstract method, and you don't have to provide the method body, only you can define. Okay, if you remove this, you have to implement that methods. Okay, if you remove the abstract non-access modifier from this method, then you have to implement the method like this method x. Okay, now guys, this abstract class can have both non-abstract methods and abstract methods. Non-abstract methods means the methods which has to be implemented. Okay, so this class A has this method implemented method, and other method we have only just defined. Okay, such classes which allow you to have this partial abstraction, that is to have normal methods and abstract methods. Those classes are known as abstract classes in Java. Okay, so abstract classes can have both abstract and non-abstract methods in Java. Okay, so you can partially implement the abstract classes. You can partially implement the abstract classes. But coming to the interfaces, you cannot implement any of these methods inside these interfaces. They are 100% abstract. You can only have, you can only define the methods inside the interface. But coming to the abstract classes, you can define the methods, and at the same time you can implement the methods also. Okay. So this is all about the abstract classes, guys. So now let's go back to the requirement so that you can understand it clearly now. What is an abstract class? Abstract class is a class which will give you the possibility of creating the methods, okay, in such a way that you can implement few methods and you can just define few methods, okay, so that those methods will be implemented by the child classes of these methods. Okay, for example, here in this case, class A has this method which is implemented, other method which is not implemented. What if I create a child class for this class A? Say I will create something like class B. Okay, finish. I'll drag it right side so that you can see both classes together. Class B, I want to make this class B a child class of the class A. How to do that? I have to use a keyword known as extends keyword. Class A. Okay, class B extends class A. Here, class B is extending the class A. That means class B is the child class of the class A. Since this abstract class has some unimplemented methods, that is abstract methods. Okay, so we are getting a compiler error saying that you have to implement the unimplemented methods of the abstract class, which is a parent class of this class B. Okay, over the mouse and select add unimplemented methods. This method y, which is unimplemented or abstract method inside the class A, will be provided here. Okay, you can implement this method, which is an abstract method of the class A, in the child class B. System.out.println, I can say inside method y, like this. Okay, so now let's go back to the requirement. Now you will fully understand this. The parent class has to provide the, for example, you got a requirement like the parent class, that is this class A, okay, has to provide the implementation of few methods. Has to provide the implementation of few methods. This method is implemented. Okay, we have implemented. At the same time, okay, it has to keep the other methods open for the implementation in the child class. So this class A, which is a parent class, has not implemented this particular method called method y, and it has kept this particular method open for its implementation in the child class of this parent class. Okay, class B is the child class of the parent class, and we have implemented this particular method which is not implemented in the parent class in the child class. Okay, so in such kind of cases where you get a requirement like this, okay, in such kind of cases you have to go with the abstract classes in Java, guys. Okay, so abstract classes are the classes which will make you implement partial abstraction. That is, you can implement few methods, you can keep some methods just defined and make them open for being implemented in its child classes. Okay, so guys, I explained a lot about these abstract classes, and this is not a complete explanation of these abstract classes, guys. Not to understand the abstract classes better, I'm going to continue the abstract classes in the coming videos. Okay, in the next videos and the coming videos, I'll be explaining more topics about these abstract classes and its properties. Fine. So that's it, guys. The next video session, I'll explain, or I'll continue with the abstract classes by explaining the abstract classes and abstract methods relation. Okay, what is the relation between the abstract classes and abstract methods? I'm going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I'm going to explain part 212 of Java for Tester series, that is abstract classes and abstract methods. Okay. So in order to make you understand the relation between the abstract classes and abstract method, let me take you to the practical mode. So let's move to the practical mode here. Inside this Java project, let's create a class. Okay, let's create a class. I'll name this class as class A. You can name it anything. Click on finish. So this class is a normal class, guys. As you can see here, public class name is a normal class. And inside this class, I'm going to create some methods. Public void some method A or method X. Okay, method X. So inside this method, I'll implement this method by writing some statement saying inside method X. Okay. Similarly, I'll create another class, another method, public void method Y. Okay. I'm going to implement this method. System.out.println inside method Y. But till now nothing happened, guys. This is a normal class, right? So till I am implementing the methods, nothing happened with this class. The normal class with normal methods. Okay. The moment I create an abstract method like this, public abstract void some method Z. Okay. When I create this abstract method, if I try to create a body, the first thing is that you'll get a compiler error saying that you cannot have a body because this method is specified with the abstract non-access modifier. When the abstract non-access modifier is specified before the methods, that kind of methods cannot have the method body like this. Okay. Over the most, you can see abstract methods do not specify a body. That means they should not have a body. What if I remove this body? Will this error will be resolved? Yes, the compiler error will be resolved, but you'll get another compiler error, okay, in a moment. So when I put a semicolon here, you see the compiler error is still there, but it's a different compiler error. Over the mouse, as you can see, you'll get a different message from the earlier. So it says that the abstract method Z, the abstract method here, name of this abstract method is method Z in type class A. In this class A can only be defined by an abstract class. That means if you are going to have at least one abstract method, okay, if there is at least one abstract method in the class, then this class has also be, okay, then this class has to be also be specified with abstract, okay. So then only the error will be resolved. So if you get a abstract method, if you have an abstract method inside a class, then that particular class also has to be specified with abstract non-access modifier. Then only the error will be resolved. The reason here is if a particular class has at least one abstract method, then that particular class has to be specified with abstract non-access modifier. You have to make this class an abstract class. Okay. If a particular class has an abstract method, then that particular class has to become an abstract class. There is no other way. So this is the relation between the abstract methods and abstract classes in Java, guys. The classes having at least one abstract methods has to be abstract classes only. Okay, normal classes cannot have the abstract methods. Fine. So that's it about the abstract classes and its relation with abstract methods, guys. In the next video session, I'll continue with abstract classes by explaining the topic abstract classes and their child classes. Okay, abstract classes and the relation between the child classes. Okay, their child classes. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I am going to explain part 213 of Java for Tester series, that is abstract classes and their child classes. Abstract classes and their relationship between their child classes. Okay, child classes of the abstract classes. So guys, what will happen when you create a child class for an abstract class in Java? Okay, that thing I'm going to practically demonstrate in this video session. So guys, before I move to the practical mode, let me tell you that when you create a child class for an abstract class, that particular child class has to implement the abstract methods of abstract class. Okay, the child class of the given abstract class has to implement the abstract methods of the parent abstract class. Okay, or if it doesn't want to implement, then you have to make that child class also an abstract class. Okay, we have to make the child class as an abstract class. Either we have to implement the abstract methods of the abstract class, parent abstract class, or we have to make the child class as an abstract class. That's the only two ways, guys. So let me show you practically so that these things will be more clear for you. Let me create an abstract class and let's create a child class for that abstract class and show you what will happen. Okay. So let's create a kind of abstract class, say class, and I will name this class as some class A. Okay, class A, and what I'll do is, otherwise I will create something like animal class, guys. Okay, it will be better. You can give any name here, guys. I'll prefer animal here. I'm just creating an animal class, and what I'm going to do here is I'm going to make this class an abstract class. Okay, by adding this abstract non-access modifier for this class has now become an abstract class. Inside this abstract class, let me create some methods. Okay, so I'll create some abstract methods. Okay, so public void eating. Okay, eating is one method. So I want to make this an abstract. So I have to put an abstract non-access modifier before this method too, so that you don't have to create any body. So inside the abstract class, I'm creating some abstract methods. So I'll create another abstract method saying public abstract void sleeping. Okay. So public void some animal. I'm just creating some sample method, but this method I don't want to make abstract. I can actually define it. As you already know, inside the abstract classes, we can have both abstract methods and non-abstract methods, right? So I'll just create some normal method. I'll say inside animal method of animal class. Done. Okay. So one abstract class I created with two abstract methods and one non-abstract method. That's fine. So I want to create a child class for this animal class. Which here animal class is an abstract class, guys. For this abstract class, I'm going to create a child class. Right click new class. Okay. I'll name this class as something like bird. Okay. Some bird class. Click on finish because bird is an animal, right? Bird is an animal. So I'm just creating a class. So I want to make this bird a child class of this animal abstract class. So how to make this bird a child class of the animal abstract class? You have to use a keyword known as extends. I have to give animal. Okay. When I say bird extends animal, animal has become the parent class of the bird and bird has become the child class of the animal class. Okay. So inside this bird class, I'm getting a compiler error saying that this bird class, since this bird class is child class of this animal abstract class, this bird class has to implement this abstract methods of the animal class. Okay, the abstract methods of the animal parent class. The abstract methods of the parent animal abstract class has to be implemented inside this bird child class. So hover the mouse, you don't have to type everything. In Eclipse side, you can simply hover the mouse on the bird and say add unimplemented methods. All the methods will be appearing here. Fine. Fine, done. So here inside this methods, I will implement something like this system.out.println. Okay, system.out.println. I'll say inside, otherwise I will say bird is eating. Okay, here I will say system.out.println. Bird is sleeping, like this. Okay, so guys, since I have implemented all the abstract methods, okay, since I have implemented all the abstract methods of this abstract parent animal class, okay, the error should be resolved now. When I save it, you see there is no error. Okay, so the child class of the abstract parent class has to implement all the abstract methods of the parent class, right? If you don't implement Okay, if you don't want to implement any of these abstract methods, for example, if the child class of this abstract parent class has only implemented the eating abstract method, but there is another method known as sleeping here, it is not implemented. In that case, guys, what's the other way? I don't want to implement that particular abstract method inside this bird class. Okay, so in that case, you have to, other option here is you have to make this bird class an abstract again. Okay, either the child class has to implement all the abstract methods of the abstract parent class, or the child class has to be made abstract type. Then only the error will be resolved. So hover the mouse, either you implement the methods or you make this class also an abstract. These are the two options, guys. Okay, these are the two options we have. Either we have to implement the methods of the abstract class, or we have to make this class child class also an abstract class, so that this error will be resolved. So who will implement now? If you are also making this child class also an abstract class, who will implement this sleeping method of this animal? The answer here is, if you create another child class, say if I create another child class like for board, I will create something like a parrot. Okay, parrot. You can give any names, guys. So that's fine. Okay, click on finish. There is another class I'm creating. I'm making this parrot class a child class of this board class, which is actually a child class of this animal abstract class. Okay, so extends. If I say bird, okay, you see again I'm getting a compiler error asking me to implement the unimplemented method of this animal dot sleeping. That is sleeping abstract class. I have to implement it saying. So if the child class, okay, if the immediate child class of this animal abstract parent class has not implemented any abstract methods, then its child class, the child class of the child class has to implement that. Okay, if this is also not willing to do that, again we have to make this parrot also an abstract case. Okay, there are only two options. Okay, either you have to make the child class an abstract class, or you have to implement all the methods of the abstract parent class. Okay, this chain will continue. If you keep on making abstract, the chain will continue. So this is the relationship between the abstract classes and their child classes in Java, guys. Child classes of the abstract classes have to implement all the abstract methods of the parent abstract class, or the child classes have to be made abstract in order to carry forward that kind of nature. Okay, so that's it, guys. It's all about abstract classes and their child classes. In the next video session, I'll continue with the abstract classes. So that is, I'm going to explain abstract classes and their method access modifiers. Okay, abstract classes and their method access modifiers of those methods which are created inside the abstract class. Okay, what kind of access modifiers we can specify before the methods that are created inside the abstract classes, that thing I'm going to explain in the next video session, guys. So that's it, guys. See you in the next video session. Thank you. Bye. Hello everyone. In this video session, I'm going to explain part 214 of Java for Tester series, that is abstract classes and their method access modifiers. So abstract classes and their method access modifiers. What are the different modifiers we have in Java, guys? There are different modifiers like private, public, protected, and default. If you don't specify anything, that generally becomes default, right? All these three other modifiers like private, public, protected, you have to specify. Fine, these are the different modifiers in Java. So guys, thing here is, in this video session, I'm going to explain that we can use any of these modifiers with the methods. Okay, we can use any of these access modifiers with the methods inside these abstract classes in Java. Okay, so in order to understand it better, let me compare this thing with the interfaces. Okay, the previous videos I explained about interfaces, and this side I'll compare these interfaces with the abstract classes. Okay, abstract classes. Fine. So what's the difference, guys? So with respect to the access modifier usage, okay, with respect to the access modifier usage, inside the interfaces, the methods are by default public type. Okay, if you don't specify any access modifier for the methods inside the interfaces, they are like public. And also if you try to provide private, protected, okay, private or protected before the methods inside these interfaces, you are going to get a compiler error. Okay, they are not supported, guys. In interfaces, the method in the for the methods inside the interfaces, private or protected are not allowed. You will get the compiler error. Okay, but when you specify public, or if you don't specify public, by default the methods are public. Okay, if you provide public also, it's public. If you don't provide public also, those methods inside the interfaces are public. But coming to private or protected, if you specify such kind of modifiers with the methods inside the interfaces, you'll get a compiler error. So what about the abstract classes? For abstract classes, there are no such restrictions, guys. Okay, you can specify private, public, protected, or default before the methods inside these abstract classes. Everything is allowed. Okay, everything is allowed. So let me show you these things practically. I click new. I'll create a class, guys. I'll name this as animal class. You can give any name here. Click on finish. I'll make this class an abstract. So this class is now abstract class. So inside this abstract class, I'll create some methods. Okay. So all these access modifiers are allowed, right? Private, public, protected, default. Let's create private void some method A. You see, this is allowed. Okay. I'm not getting any compiler error. What if I say public void some method B? This is also allowed. Inside the abstract classes, all these things are allowed. Private, public, protected. Okay. Protected void some method C. This is also allowed. And here void some method D, default access modifier before this method. So all the access modifiers like private, public, protected, and default are allowed for the methods inside the abstract classes. So if I check the same with the interfaces in Java, let me create an interface. I will create an interface name bank. Click on finish. Let me move it side by side so that you can see both abstract class and interface at same time. Inside this interface, if I try to create some methods and provide this different type of access modifiers, what will happen? Let's see. So I'll start with private void some method A. Okay. So immediately illegal modifier it's saying. Okay. Illegal modifier for the interface method A. You cannot provide private. What about protected? Can I provide protected? Even I'm getting the same thing. You cannot use protected also. So can I make it public? Yes, I can make it public, but this method body will not be there, general, right? So if I make it to private, I'm going to get a compiler error. For protected also, I'm going to get a compiler error. But for public, you see, public is allowed. What if you don't provide public here? By default, it is public only, guys. By default, the methods inside the interfaces are public type. Okay. If you don't specify or if you specify explicitly, these methods are public by default. Okay. These kind of rules are only specific to the interfaces, guys. But coming to the abstract classes, there are no such rules. You can use either private, public, protected, and default access modifier for the methods which are created inside the abstract classes in Java. Okay. Unlike interfaces, we can use any type of access modifiers for the methods which are created inside the abstract classes in Java. So guys, that's the relationship between the abstract classes and their method access modifiers. In the next video session, I'll explain more about these abstract classes, that is abstract classes and their object creation. Can we create objects for the abstract classes in Java or not? That thing I am going to explain in the next video session. So that's it, guys. See you in the next video session. Thank you. Bye. Hello, everyone. In this video session, I am going to explain part 215 of Java for Tester series, that is abstract classes and object creation. So abstract classes and object creation. So can we create objects for the abstract classes in Java or not? The question here is, can we create objects for the abstract classes in Java? The answer for this question is no, guys. We cannot create objects for the abstract classes in Java. Okay. So let me show you practically. So what will happen when I try to create an object for the abstract classes in Java? I'm going to get a compiler error. Okay. I'm just going to get a compiler error. So let me practically demonstrate that objects cannot be created for the abstract classes in Java. And on doing so, you are going to get the compiler error. So for that, let's go to this Java project, create a new class, normal class I will create first case. I'll name this class as animal. You can name it anything. Click on finish. And the normal class. In order to make this normal class an abstract class, you have to add this abstract non-access modifier before this class. Abstract. Okay. When you add this abstract non-access modifier before this class, this particular class will now become an abstract class. Inside this class, you can create some variables and methods. Okay. Int speed. Int speed is one variable. Okay. Int speed is one variable. Int flex count. You can create any number of variables, guys. It's up to you. And variables are fields, you can say. And you can create some abstract methods or non-abstract or normal methods. Okay. So let's create some abstract method first. Public abstract void eating. Okay. Eating. Eating is a method name. So this is an abstract method, guys. This abstract method doesn't have any body, as you already know. And I'll create a normal method now. Inside the abstract classes, we can also create the normal methods. I'll say public void sleeping. Okay. So inside this method, I will say system.out.println animal is sleeping, like this. Okay. So anyhow, all these fields and methods are inside this abstract class, right? The sample abstract class I created. So let's find it out whether we can create some object for this abstract class animal or not in this example. So for that, let's create a new class known as demo. You can give any name here. Select this public static void main so that this code will be auto-generated. Just drag it here to the right side so that you can see both this animal class and demo class together. Inside this main method, I'll try to create an object for this animal abstract class. But before doing so, I'm saying that you are going to get a compiler error because Java doesn't allow you to create some objects for the abstract classes. So animal A is equal to new animal. If I try to create an object, okay, for the abstract classes in Java, you're going to get a compiler error saying that cannot instantiate the type animal. That means you cannot create object for the abstract classes in Java. It's simply saying, okay. So it's not possible, right? So it's not possible. Is there any way that I can access these variables and methods of this abstract class? Yes, guys. Even though you're not able to create an object for this animal abstract class here, you can actually, okay, there is a process where you can actually access them, okay, outside this abstract class. How to do that? For that, let's create another class. Say, I'll say bird, okay, some other class named bird, and I will make this bird class extend this animal class. That means I will make this bird class a child class of this animal parent class. Okay, how to do that, guys? I have to say extends animal. So on doing so, immediately I will get a compiler error saying that there is one abstract method inside this animal abstract class. You have to implement that. Okay, it says over the mouse and say add unimplemented methods. So whatever the abstract method is there, that is eating, that need to be implemented inside this bird class. Okay, so I'll say system.out.println bird is eating. Okay, bird is eating, I will say. Now guys, once you have created a child class for this animal parent class, okay, I cannot create an object for the animal parent abstract class here because animal parent class is an abstract class. I cannot create object, but I can create an object for the child class of this animal class. Okay, so and access all these variables and methods which are inherited by this bird class from the animal abstract class. So since bird class is not an abstract class, I can create an object. I'll simply say bird v is equal to new bird. Okay, using the object reference of this bird, I will say b dot. Okay, you see speed is able to access. We are able to access the speed, guys. B dot speed is equal to some 5, I will say. Okay, and b dot lex count something like 4, I will say. Then I'll say b dot sleeping. Okay, this one is from the animal abstract class, implemented in the animal abstract class. Another one is eating, which is abstract method inside this animal abstract class, which is implemented in the bird. So I can even call that b dot eating, like this, guys. So even though you're not able to create an object for the abstract classes in Java, you can actually, okay, create a child class for that abstract classes, and using the object of this child class, you can access all the inherited variables and methods from the animal class. Okay, fine. So this is how we have to, okay, work with object creation in case of the abstract classes where object creation is not possible, but we can create objects for the child classes of those abstract classes. Okay, so this is very similar to the interfaces, guys. The same applies for the interfaces in Java, right? So it's not only for abstract classes, guys. In Java, for interfaces also, you won't be able to create any objects. Okay, when you do so, you'll get the compiler error similar to this abstract classes. Okay, both have the same properties where you cannot create objects for the abstract classes or interfaces. Regarding the interfaces and object creation, I already covered in one of the previous videos, guys. Okay, so that's all about the abstract classes and object creation, guys. In the next video session, I'll continue with the abstract classes concepts, that is abstract classes and their fields. Okay, so that's it, guys. See you in the next video session. Thank you. Bye.